이야기합시다.
예, 딱 걸린다. 예, 안녕하세요. 그 WebRTC 커뮤니티 리더를 맡고 있는 최진호입니다. 반갑습니다. 오늘 그냥 미덕도 아니고 빅 미덕이죠. 그 글로벌한 WebRTC 락스타들과 함께 하고 있습니다. 이분들이 싱가포르를 거쳐서 한국, 동남아 순회군을 거쳐서 한국, 그 다음에 일본으로 가는 어마어마한 여정 중간에 저희 한국을 들려서 미덕을 하고 있고요. 이번 기회에 다시 한번 감사 말씀드리겠습니다. 그 5분의 락스타 분들에게 한번 박수 한번 쳐주십시오. 그 행사를 준비하면서 이런 메일이 왔어요. 그 대부분 미덕의 강사들이 다 외국인인데 영어를 잘 못하는데 들어와도 되냐라고 하셨는데요. 답변을 드리기를 우리도 영어 못한다. 나도 영어 못한다. 근데 이분들이 역시 스타더라고요. 그래서 저희가 하는 영어들을 되게 잘 이해하시고 그래서 좀 여러분들이 질문 있으시면 뭐 부끄러워하지 마시고 그냥 얼마든지 질문하셔도 되게 친절하게 답변해 주시더라고요. 그래서 부담 갖지 마시고 질문해 주셨으면 좋겠습니다.
WebRTC Rockstars. 다음에 이제 최준 대표님 다음에 이제 발표해 주신 이제 알렉스 구알리아르, 그래서 줄여서 그냥 알렉스라고 부릅니다 저희가. 그래서 이름 보시면은 구알리아르 이렇게 돼 있죠. 그래서 이분은 저희하고 이렇게 굉장히 인연을 맺고 있고요. 지금 우측에 보시면은 저 사진이 제가 왜 났는지 모르시겠죠. 저게 애플에서 WebRTC 지원한다고 했잖아요. 그때 저기 보시면은 애플과 구글이 알렉스의 사무실에서 같이 만나서 이제 얘기하고 있는 그런 역사적인 사진, 저는 굉장히 역사적인 사진으로 생각하고요. 그래서 WebRTC 쪽의 프로토콜이나 이런 미디어 쪽의 코어 쪽에 관한 부분의 표준을 담당하고 있고요. 활동을 굉장히 많이 하고 있습니다. 그리고 오늘 발표해 주실 내용은 카이트인데요. 이게 이제 WebRTC 호화 테스트를 사실 많이 해야 돼요. 우리나라는 좀 어떤지 모르겠지만 이제 사실 그 이슈가 이제 최근에 조금 많이 올라오고 있고, 그래서 구글이 이제 알렉스가 만들고 이제 구글이 이걸 채택했습니다. 그래서 호환성 테스트 할 때 이걸 하는데요. 밑에 보시면 여기 이게 뭔지 K의 가로시인데 무슨 뜻인지 모르시죠? 일본어고요. 괄호사예요, 괄호사. 그래서 테스트를 얼마나 많이 하면 괄호사냐라는 것도 재밌게 굉장히 코믹하게 지은 내용입니다. 그래서 실제 테스트하면 600 몇십 개가 되거든요. 좀 이따 발표 들어보시면 됩니다. 그리고 다음은 이제 우리 WebRTC 락스타스가 된 게 이제 주로 우리 로렌조 때문에 이제 락스타가 좀 됐어요, 컨셉이. 그래서 우측에 보시면 여기 이제 중국에서 발표한 내용인데 락스타죠. 그래서 이렇게 됐고, 제임스라고 우리나라 말로는 야누스 많이 들어보셨을 겁니다. 오픈소스 미디어 서버 쪽에서 이제 이제 유명한 서버죠. 프렌토 있고, 그다음에 야누스 있고, 요즘에 야누스가 잘 나갑니다. 그래서 이제 야누스에 대해 설명해 주실 거고요. 댄 버넷인데, 댄 버넷은 표준 활동을 약 20년 정도 했어요. 그러니까 웹 표준 그러면 댄 버넷 굉장히 하고요. WebRTC 처음에 문서 작성했던 분이 이제 댄 버넷입니다. 그래서 그분을 모시게 돼서 항상 영광이고요. 알게 돼서 영광이고요. 그리고 오늘 발표 내용은 이제 All Things RTC라고 해서 WebRTC를 계속하지만 사실은 항상 이런 질문이 나와요. 어떻게 시작해야 됩니까? 아이디어는 뭡니까? 기초적인 질문이 계속 나와요. 되게 부끄럽지 않은 질문이 해외에서도 하는 질문입니다. 그런 어떤 것들을 좀 해소하고자 새롭게 이제 만든 사이트고요. 주로 이제 요즘 콘텐츠가 좀 올라와서 인터뷰 내용이 좀 꽤 있어요. 그래서 그런 걸 보시면은 인사이트도 많이 얻으실 것 같고요. 그런 내용으로 발표해 주실 거고요. 그리고 조던은 지금 한국에 온 이유가 한국이 이제 e스포츠 게임의 강국이잖아요. 그래서 그것 때문에 굉장히 익사이팅해서 봤어요. 그래서 혹시 참석하신 분 중에 게임 쪽에 계신 분이 있다면 조던하고 컨택을 좀 해주시면 감사하겠습니다. 조단이 지금 만든 그 솔루션은 뭐냐면 팀들의 각자 화면을 한 화면에서 보는 거예요. 근데 이게 WebRTC로 만들어졌고요. 아까 이제 제가 오면서 잠깐 얘기를 했더니 이제 저도 어디에 쓰이면 좋을까? 이제 물론 이제 팀워크하면서 쓰인다고 생각을 했었는데 이제 게임 매니저 있잖아요. 게임 매니저가 이제 팀워크해서 게임을 할 때 그때 이제 매니저들이 활용한다면 좋겠다. 뭐 이런 얘기를 좀 했고요. 그리고 크리스는 혹시 그 해외 쪽에 이 행사 내용에 좀 관심 있으신 분은 많이 알 겁니다. 크랭키 기 WebRTC 쇼라고 해서 연초, 연말에 뭐 유럽에서 한 번, 뭐 미국에서 한 번, 이 정도 뭐 행사를 하고 있고요. 오늘 발표해 줄 내용은 그 최근에 있었던 그 WebRTC 행사 내용이 거기에 페이스북, 우리 잘 못 만나봤던 페이스북, 슬랙 이런 친구들이 발표한 내용들 나오고 굉장히 재밌는 얘기가 많습니다. 머신러닝 얘기도 나오고요. AI 뭐 이런 얘기도 나옵니다. WebRTC와 상관없을 것 같은 그런 얘기들이 있으니까 참조하시면 될 것 같고요. 예, 다시 한번 one more time welcome WebRTC Rockstars. 저는 이렇게 소개를 마치고요. 이제 우리 최진호 대표님 박수 쳐도 됩니다. 감사합니다.
바로 시작하겠습니다. 제가 오늘 말씀드릴 내용은 브로드캐스트 파스, 방송을 위한 파스를 좀 말씀드리려고 합니다. 참고로 저를 잠깐 소개해드리자면 2013년부터 SK텔레콤에서 우리나라 최초의 C파스죠. WebRTC 파스인 플레이RTC를 처음 기획을 해서 개발한 프로덕트 매니저 역할을 했고요. 작년까지 하다가 이제 나와서 다시 리모트몬스터의 대표로 좀 일하고 있습니다. 어떻게 보면은 두 번째 벌써 파스를 만들었는데요. 벌써 한 4년, 5년이 벌써 됐죠. 그래서 지금 만들면서 리모트몬스터 클라우드를 만들면서 국내에 유의한 WebRTC C파스를 만들어 왔죠. 사실 처음에 했을 때는 우리나라에 이런 WebRTC 파스를 쓰시는 분들이 계실까 많이 고민했었는데 생각보다 많은 분들이 영상통신 기능을 이용해서 다양한 서비스들을 만드셨고요. 저희가 그런 서비스가 성장하는 데 많은 도움이 돼서 정말 기뻤습니다. 그래서 뭐 10개 이상, 사실 몇십 개의 고객들이 있었는데 실제로 성공이라고 해야 될까요? 오픈하고 고객들을 모아서 그 서비스가 성공하는 거는 한 10분의 1밖에 안 되더라고요. 그래서 하지만 그런 다양한 서비스들이 성공하는 데 있어서 밑거름이 될 수 있는 파스 역할을 해서 되게 너무 좋았어요. 그래서 1년 동안 진행하면서 트래픽도 최근 들어서 많이 급성장하면서 약간 이제 먹고 사는 데는 약간 그래도 큰 문제는 없이 잘 살고 있습니다. 근데 저희가 내년부터는 그 C파스, 즉 커뮤니케이션 파스가 아니라 브로드캐스트 파스를 준비하고 있어요. 방송 시장에 이제 눈을 돌린 건데요. WebRTC로 왜 방송을 할까? 방송 파스가 정말 필요할까? 라는 질문을 많이 하실 것 같아요. 아시는 것처럼 모바일에서 거의 유일하게 성장하고 있는 트래픽이나 콘텐츠가 영상이더라고요. 뭐 이미지나 뭐 그런 쪽 콘텐츠보다 확실히 영상이, 여러분들 유튜브 없이는 못 사시잖아요. 특히 젊은 사람들은 더 심할 텐데, 그런 영상 중에서도 특히 뭐 아프리카 TV를 위시한 그런 생방송 시장이 정말 많이 성장을 하고 있습니다. 그러니까 뭐 우리나라도 마찬가지지만 중국 같은 경우에는 뭐 시장이 어마어마할 뿐만 아니라 앱들도 되게 많아요. 그 생방송 시장이. 그래서 그런데 반해서 우리나라뿐만 아니라 전 세계적으로 방송 서비스를 하나 만든다라고 했을 때 보통 보니까 다들 와우자가 거의 대다수를 이루고 있더라고요. 와우자가 10년 이상 된 기술이거든요. 솔루션인데 설치형으로 해서 와우자를 해서 방송을 만들고 있죠. 우리나라는 특히 와우자의 점유율이 더 높고요. 근데 사실 뭐 와우자도 좋습니다만 사실 여러분들이 이렇게 아시는 것처럼 이제 레이턴시 문제라든지 뭐 항상 그런 건 아니지만 액티브엑스를 쓸 수도 있고, 그다음에 모바일 네트워크 환경을 고려하지 않은 그런 스트림 처리 문제라든지, 또 트랜스코딩이나 그런 것들을 막 자주 해야 되다 보니까 좀 방송 서버가 무겁다라는 그런 부분들도 많이 있고요. 그런데 저희가 생각하기에는 가장 큰 문제는 다른 기술들은 다 클라우드에 다 올라가 있고 클라우드를 이용해서 개발을 할 수 있는 환경이 잘 갖춰져 있어요. 얼마나 개발이 쉽습니까 요즘에. 그런데 방송만은 유독 그렇지가 않아요. 이제 앞서 설명드렸던 여러 가지 설치형 솔루션 때문에 방송 서비스를 만들려면 정말 많은 것들을 알아야 되더라고요. 그래서 그런 고민을 했죠. 그 방송이 왜 클라우드 기술로 안 되지? 그래서 WebRTC의 기술과 클라우드 기술을 이용해서 방송 기술의 미래를 한번 열어보자라는 측면에서 저희가 도전을 하게 됐고요. 아직은 미숙하지만 그렇게 하게 된 이유는 기본적으로 기존의 방송들은 뭐 여러분들이 이렇게 아시는 뭐 아프리카 TV든 뭐 트위치든 뭐든 간에 트위치는 모르겠네요. 방송을 송출하는 쪽과 그 방송을 보는 쪽이 하나의 프로토콜로 되어 있다고 볼 수 없는 상황들이 많았기 때문에 코덱이라든지 중간에서 트랜스코딩을 해야 되는 이슈들이 있어요. 근데 WebRTC는 시청과 송출 양단이 WebRTC라고 가정을 한다면 이런 트랜스코딩에 드는 비용이 되게 적게 되기 때문에 훨씬 더 아키텍처적으로 유리한 부분들이 있죠. 그러다 보니까 이제 이런 아키텍처의 단순함 때문이기도 하겠지만 어쨌든 레이턴시 1초 미만의 세계를 접할 수가 있게 되는 겁니다. 저는 이게 되게 크다고 봤어요. 기존의 방송을 만드시는 분이나 개발하시는 분이나 보는 분들은 뭐 지금도 괜찮은데 뭐 5초, 20초, 30초 느리는 게 그렇게 큰 문제인가? 라고 생각할 수 있는데 우리가 3G만 접하다가 LTE 접할 때는 그렇게 빠를 필요가 있어? 라고 했는데 LTE의 세계에 지금 3G로 하려고 하면 너무 답답하잖아요. 그만큼의 세계의 간극이 존재하다는 걸 저희가 느꼈습니다. 이런 WebRTC로 방송 서버를 할 때 가장 기본이 되는 서버 기술이 셀렉티브 포워딩 유닛이라고 해서 SFU라고 하는 건데요. 쉽게 말하면 기존에는 A, B, C, D의 영상을 시청자한테 보여주려면 영상을 믹싱해가지고 합친 다음에 시청자가 원하는 사이즈로 트랜스코딩을 해서 이제 뭐 보여주는 방송이라고 한다면 SFU는 A, B, C, D의 영상을 시청자한테 그냥 그대로 보내줘요. 생각 안 하고 그냥. 얼핏 생각하면 너무 단순한 방식일 텐데 오른쪽에 보는 것처럼 그렇게 멍청하지만은 않아요. 시청자가 좋은 네트워크와 좋은 디바이스인 경우에는 좋은 영상을 보여주고 그렇지 않은 경우에는 좀 품질이 낮은 영상을 보여줌으로써 좀 더 비용 효율적인 부분들을 많이 고려한 서버라고 보면 됩니다. 이게 WebRTC에서는 방송에서는 많이 쓰이고 있는 기술이죠. 오픈소스로도 꽤 많이 나와 있어요. 해외 사이트 들어가 보시면 생각보다 많이 있고 그 상용으로 쓰기 위한 기본적인 기능들은 잘 갖춰져 있습니다. 이따 설명을 좀 드리고요. 그런데 이제 그 상용으로 쓰기 위한 기본 엔진이 있는 거지 그것이 실제 상용의 어떤 모든 것들을 만족시키는 건 아니죠. 어쨌든 그런 이제 SFU를 저희는 기존에 저희가 가지고 있는 C파스에다가 SF를 얹어서 방송 파스를 만들게 됐습니다. 그 아키텍처는 뭐 쉽게 보면 오른쪽에서 시청자나 이제 방송 방송자가 방송을 하거나 했을 때 이제 SK를 이용해서 하면 이제 리모트몬스터의 비파스에서 API 서버와 뭐 그런 백엔드에서 관리해주는 게 있고, 방송을 내가 만든다라고 하면 그때 클라우드에서 즉시 컨테이너 기반으로 해서 서버가 디플로이가 그때 되거나 필요한 만큼만 적재되어 있던 서버가 방송을 위해서 디플로이가 됩니다. 항상 예전 같은 경우에는 방송을 위해서 IDC 센터에 방송 서버 풀을 되게 크게 가지고 있는 상태에서 트래픽이 많거나 적거나 상관없이 그걸 계속 유지하고 있었어요. 이제 클라우드로 방송이 옮겨지면서 항상 방송 서버가 피크 타임도 아닌데 계속 자원을 낭비할 필요 없이 컨테이너에서 이미지를 가지고 있다가 트래픽이 몰린다 했을 때에만 클라우드에 의해서 디플로이가 되는 이런 좀 유연한 스케일러빌리티를 아키텍처를 구성을 했습니다. 그래서 이렇게 되면 이제 클라우드는 사실 뭐 지역적인 제한이 없잖아요. 한국, 미국 뭐 어디든지 그 방송자가 원하는 곳에다가 바로 방송을 해서, 사실 방송에서 제일 중요한 거 저희는 레이턴시라고 생각을 해요. 미국에서 방송을 한다면, 시청자가 미국에 있다면 방송 서버가 미국에 있어야겠죠. 그것이 어떤 설계가 뭐 특별히 그 전에 할 필요 없이 언제든지 바로 자동으로 방송이 이루어질 수 있게 하는 그런 아키텍처를 구현을 하고 있습니다. 아까 말씀드린 대로 비파스의 장점은 속도일 텐데요. 아까 계속 말씀드렸기 때문에 속도는 재미난 예를 말씀드리면 저희가 방송 서비스를 하나 예제로 만들었을 때 고등학생들을 대상으로 한번 소개를 한 적이 있는데 그때 깜짝 놀랐어요. 이게 저희 서비스를 만지자마자 바로 첫 번째 피드백이 뭐 재밌어요 그게 아니라 왜 이렇게 빨라요? 라고 하시더라고요. 그리고 했던 것이 바로 뭐냐면 소통 방송을 바로 하시더라고요. 키보드를 놓지 않으시더라고요. 그래서 이게 레이턴시가 20초 걸렸을 때와 레이턴시가 1초 미만일 때의 방송의 어떤 스타일이 달라진다는 걸 많이 느꼈습니다. 훨씬 더 인터랙티브해지고 훨씬 더 잦은 통화 같은 방송을 하는 것을 많이 느꼈어요. 그래서 이 속도에 대한 거는 앞으로 모바일 생방송에서 되게 중요한 요소가 아닐까. 그래서 WebRTC 기반의 꼭 비파스가 아니더라도 WebRTC 기반의 방송은 앞으로 인터랙티브한 생방송에서 되게 중요한, 내가 이제 방송자한테 문자를 보냈는데 그게 20초나 30초 뒤에 전달이 되면 그걸 대화할 수는 없잖아요. 그런 측면에서는 WebRTC가 앞으로 많이 뜰 것 같고, 실제로도 마이크로소프트가 트위치에 대항해서 믹서라고 하는 WebRTC 기반의 방송 서비스를 만들었거든요. 게임 방송용. 그거의 가장 큰 장점 중에 하나가 1초 미만 방송이었어요. 그래서 점점 그 모바일 방송에서 WebRTC가 속도를 무기로 기존의 설치형 솔루션 시장을 잠식해 갈 거라고 저는 생각을 하고 있습니다. 비파스만의 장점은 아시겠지만 방송 서버 기술을 몰라도 엔지니어가 쉽게 방송 서비스를 만들 수 있다는 거죠. 사실 방송 서비스의 핵심은 기술이 아니라 컨텐츠잖아요. 판타지. 내가 평소에 볼 수 없는 누군가를 만날 수 있다는 거, 아니 평소에 볼 수 없었던 어떤 컨텐츠를 만났다는 게 사실은 방송에 제일 중요한 건데, 그 방송 기술 때문에 그런 서비스를 못 만드는 사례를 많이 봤기 때문에 비파스의 장점은 빠른 개발이 아닐까라는 생각이 듭니다. 그리고 또 하나는 이제 컨테이너 기반의 방송 서버인 거죠. 저희는 방송 서버를 확장하는데 10초면 100대가 확 생겨요. 예전에 상상할 수 없었던 거죠, 정말. 내일 무슨 뭐 아이유가 갑자기 방송을 해. 그러면 그 전날 IDC 가서 막 장난 아니에요. 세팅하는 게. 근데 저희는 10초는 너무 심했나? 5초요. 5초인가요? 아무튼 그만큼 빠르게 쉽게 그냥 바로 100대가 그냥 100대가 더 100대든 몇 대든 상관이 없어요. 그냥 쫙 하면 그냥 빡 올라갑니다. 그런 유연한 확장성, 거의 무제한급의 확장성을 저희는 제공을 하고 있다는 게 가장 큰 장점이죠. 저희도 하면서 많이 놀라요. 네. 이거는 말이 안 되는데? 그런 생각을 합니다. 저희 미더블은 remotemonster.com 미더블을 통해서도 여러분들이 보실 수 있는데요. 행사 때문에 잠깐 급하게 만든 페이지에서 좀 허접하긴 한데요. 이런 페이지를 만드는데 소스 코드가 이 정도면 그냥 방송 서비스 하나를 만들 수 있을 만큼 개발을 해서는 되게 빠르게 하루 만에 만드는 것까지 하루 만에 급하게 만들게 이틀 정도 됐습니다. 아무튼 네, 그렇게 해서 만들었고요. 소스 코드도 되게 단순해요. 뭐 주어줄이면 방송 서비스의 핵심 코드를 만들 수 있을 정도로 되게 단순하게 만들었기 때문에 이런 겁니다. 보시면 아마 레이턴시는 되게 빠른 페이스북도 지금 같이 방송하고 있거든요. 페이스북이랑 비교해보면 레이턴시가 이렇게 빠르구나라는 걸 아마 느끼실 수 있을 거예요. 근데 이제 질문을 좀 받아야죠. WebRTC가 정말 최고의 방송 기술이야? 라고 하면 그렇지는 않아요. WebRTC는 속도에 되게 최적화되어 있는 방송 기술이죠. 아까 말씀드린 것처럼 인터랙티브한 방송에 되게 어울리는데 좀 품질을 많이 생각하는 버퍼링을 통해 가지고 캐시나 버퍼링을 통해 가지고 해야 된다면 저는 이제 HLS를 추천해 드려요. 특히 이를테면 막 WebRTC로 AR, VR을 하신다는 분들이 있어요. 근데 실제로 가지를 하시는 분들도 계시긴 한데 저는 그거는 추천해 드리지 않습니다. VR 같은 경우에는 일단 레졸루션이 상당히 좋아야 어떤 체험적으로 되게 어떤 현실감을 느낄 수 있기 때문에 WebRTC는 빠른 대신에 제대로 만약에 전송이 안 될 경우에는 많이 좀 지터를 하지만 버리는 경우가 많이 있기 때문에 대용량의 고품질의 영상을 원하신다면 HLS나 뭐 기타 여러 가지 프로토콜을 쓰시는 게 맞고 WebRTC는 속도나 인터랙티브한 방송에 훨씬 더 어울린다고 저희는 생각을 합니다. 야구 경기 같은 거 그런 거는 화질이 되게 중요하잖아요. 야구 경기를 언젠가 한번 제가 커넥팅해 야구 경기를 정말 QHD에 VR로 중계해주는 서비스를 만든 회사에 방문한 적이 있는데 그런 경우에도 이제 WebRTC는 어울리지 않습니다 라고 말씀드린 적도 있어요. 그 다음에 이제 또 중요한 게 미디어 서버를 뭘 써야 되지? 라고 하는 경우가 있는데 저희가 거의 대부분을 써봤어요. 여기 야누스의 로렌조도 맞지만 사실 저희가 생각할 때는 오래된 게 좋겠죠? 그런데 사실 거의 대부분이 어느 정도는 기본적인 성능이나 그런 부분들을 만족하고 있어요. 장단점도 있고요. 어떤 걸 쓰더라도 사실은 동쾌하고 사실 저희도 여기 있는 거에 지시를 제외하고는 야누스도 이제 거의 쓰려고 노력하겠지만 거의 대부분을 써도 되는 아키텍처로 되어 있어요. 다 장단점이 있거든요. 그래서 여러분들이 만약에 저희 걸 안 써도 되니까 미디어 서버 중에 어떤 걸 쓰는 게 좋아요? 라고 물어보신다면 나중에 좀 저희 경험담을 따로 말씀을 드리도록 할 텐데요. 다 좋습니다. 다 좋고요. 예. 근데 C를 잘 하셨고 하시는 분들은 보통 야누스를 되게 많이 선호를 하시는 것 같고, 자바를 좋아하시는 분들은 좀 GC 같은 걸 좋아하셨던 것 같기도 하고, 오랫동안 하셨던 분들은 프렌토를 안정성이나 그런 측면에서 좋아하시는 것 같고, 자바스크립트를 좋아하시는 분들은 미디어 속을 좀 선호하시는 것 같고, 그런 특성이 좀 있는 것 같습니다. 그리고 또 하나가 가장 큰 문제가 사실은 빅 트랜잭션이 가장 큰 문제예요. 1000명, 10,000명, 10만, 100만 명의 사용자들을 어떻게 잘 서비스하지는 미디어 서버가 기존에 지금 소개해드린 미디어 서버가 해줄 수 없는 또 다른 영역이에요. 그것도 저희의 숙제입니다, 사실. 저희가 지금 이거를 위해서 열심히 노력을 하고 있어요. 오픈소스로는 해결이 안 돼요. 오픈소스는 그냥 빅 트랜잭션, 프로덕션 레벨에서의 성능을 보장하는 것은 또 다른 세계입니다. 그래서 이 부분들은 많은 노력이 필요하고 아마 많이 필요합니다. 특히 이제 HLS 같은 경우에는 안템피도 상관없는데 이렇게 트래픽이 많으면 이제 HLS CDN으로 보내버리면 되거든요. 단순해요. 그냥 거기서 싸주면 되니까 속도는 느리지 않죠. 근데 WebRTC 같은 경우에는 어떻게든 서버가 그걸 다 해결을 해줘야 되거든요. 근데 하나의 서버가 받을 수 있는 대역폭은 네트워크적으로 물리적으로 한정되어 있죠. 그럼 결국은 이제 엣지라고 하는 형태로 엣지로 그것들을 전달시켜서 대신 처리할 수 있게 하는 그런 아키텍처를 잘 구성을 해야 되고, 특히 저희처럼 서버가 있다가 없다가 그런 되게 유연한 환경에서는 그것들을 더 잘 처리해야 되겠죠. 이미 그런 것들을 스태틱하게 만들어 놓은 아키텍처인 경우에는 하면 되겠지만, 저희처럼 되게 유연한 아키텍처에서 더 그런 부분들이 더 챌린지업을 하고 되게 중요한 기술 중에 하나가 될 겁니다. 이거는 아마 해외에서 이런 내용들에 대한 것들이 많지는 않고, 앞으로도 WebRTC 방송을 하는 사람들은 다 같이 모여서 해결을 해야 되는 부분이라고 생각이 듭니다. 그리고 WebRTC 방송이 아직도 갈 길은 많이 있지만, 아까 말씀드렸던 여러 가지 사례들이나 그런 걸 통해서 저는 앞으로 이제 모바일에서 개인 방송이나 생방송은 WebRTC가 그냥 기본 디폴트 이거의 시대가 내년에 올 거라고 생각이 들고, 같이 저희 페이스북의 그룹에서도 WebRTC 관련된 방송 기술에 대해서 같이 논의할 수 있으면 좋겠습니다. 내년에 같이 페이스북 그룹에서 많은 기술적인 내용들을 공유했으면 좋겠습니다. 네, 감사합니다.
네. 스테이지로 모시겠습니다.
Hi. Well, hello everyone. It's very nice to be back here in Korea 1 year later. Just 1 year, almost day for day, we did the first WebRTC meetup here in Korea since we have a IETF meeting, thanks to the support of the local community. And it's nice to see familiar faces that were here last year, and also a lot of very new faces, including new invited. So it was very unfair that they didn't want to do IETF in Korea again this year. They did it in Singapore, so we said, okay, that's fine. We're still going to bring the show to Seoul and speak a little bit about the new things that happened during that 1 year. So I'm going to speak about something that is a little bit boring, but everybody needs to do. And the good news is we did it for you, so you're going to be happy for it. It's testing. Just before, in the introduction, people say it's very difficult to go large scale, do big transaction, and have a lot of big people using WebRTC. If you compare it to Flash or HLS or other technology, it doesn't seem as production ready, right, as the other technology. Well, Flash has been around for 20 years, so they had time to test and fix. WebRTC has just become a recommended standard 1 week ago, right? So it takes a little bit of time to make it technology that is as mature as a 20 years technology. Now that being said, you have services like Facebook Messenger, WhatsApp, and a lot of others. But not using WebRTC or one flavor of WebRTC today, for very, very large transaction volume. So at the same time, it seems like a young technology. On the other hand, you have a lot of big companies using it today that can give us faith that it's stable enough for production. So what is the problem about testing WebRTC that we didn't have before? So most of the time when you develop a new JavaScript API for the web, part of the process is to write some tests. So at the W3C, which is the consortium that defines all the new JavaScript API for the web, and for the browsers, HTML5 and many, many other more, you have what is called a web platform test. They like dinosaurs. I don't know why, so I took the picture. It's cute. They have a GitHub webpage where everybody can actually come and write new tests. So if a student, it's fantastic because you can participate into defining the web for the entire world by writing a few lines of tests. And usually, it's an easy entry point for a student to actually start working with the standards. Because you can take a very simple test and start writing it, understand a little this, and then a bigger one, and build up your expertise like that. For people in the industry, of course, that's a little bit less interesting. But the point is, the test exists, and you need to go through the test in order for a standard to become ready. So 1 year ago, we had only 10% of the JavaScript API for WebRTC tested. As of last week, we have 70%. And that's one of the reasons why it could become a recommended standard last week as well. If it's not tested enough, we don't want to give it to you because then you have to clean the house for it. But that was good news. It's just a normal standard test, JavaScript, and you can go ahead. So the problem with that when it comes to WebRTC is usually the JavaScript API are made to run in one browser at a time. Most of the people that write usual web application are only interested in one thing. I want my website to look the same and to behave the same, whatever the screen size, whatever the operating system, whatever the browser, right? I want it to work on Internet Explorer and to look the same with the same colors in Chrome or in Safari on iOS. That's really the only thing I'm interested in, because my web application is going to speak to the server, and that's it. So I'm going to have standalone tests, and I'm going to test them in one browser at a time. No, I don't know which button is the right one. No? No. Next. Now, with WebRTC, you start having P2P communication. Your web application will be open in Lorenzo browser, and it's going to be open in my browser, and we're going to try to communicate together directly, without going through a server. So now, if I want to test that, I cannot test that one browser at a time. I need at least 2 instances of the web application running in parallel in 2 different browsers and speaking to each other. And that's a kind of test that we didn't have to do before. So we're going to differentiate the 2 tests by calling the first one compliance and the second one interoperability. And because we never had to do it before, it was hard. There was no tool to do that, and we had to do it manually, right? So if you draw and put some colors, because it's always easier to understand, the usual compliance test, you will have one app running in a browser and speaking possibly to a server in the backend. Or if you use WebRTC, you're going to have a direct connection here between 2 browsers. And now suddenly it's difficult, because if you have 5 browsers, you have 25 pairs. Right? So the number of tests is not a linear number, it's now a matrix of tests and so on and so forth. So, all right, the tools were not here. How bad is it really, right? What's the problem? Is it really important? So let's say I'm going to look at all the interesting configuration, right? So I'm going to take iOS, Chrome 49, iOS, Baucke, iOS, Chrome 51, and so on and so forth. And I'm going to map all the configuration around the circle. And now I'm going to try to do a one-to-one call between all the possible configuration. Don't try that at home. So 2D matrices are not very nice. So I went into binding like that. And you realize that even with a very limited subset, that's only the latest stable browser and 2 revisions in the past, which is not a lot, actually. You already have 500 cases, and that's only one-to-one call. So that's what you want to test, but what can you test with the tools that existed last year? Well, you could only test one operating system at a time, really, not two. So you were limited to all the tests between browsers that were running on the same operating system, which are there, right? And so you can, technically speaking, you could only test 23% of what you wanted to test. And it's actually really worse than that because that's what we actually tested. And when I say we, there was all the browser vendors together when they were running the test. They were running only 6 cases, which was Chrome against Firefox on Debian. And everybody knows, most of the people on the planet use Linux as a computer, right? So it was very, very representative to the case you wanted to test. That was bad. So we said, okay, I'm not going to test those 500 tests and all 1,000 or whatever by hand. I'm going to die. And we tried, and we barely escaped death. So we're going to create a testing engine that is going to run the test for me on all the possible configuration I want. That little diagram at the beginning with all the binding, I'm going to let the computer do it for me, right? And I'm going to avoid death by overwork. So I want to be able to run the test on all the operating system of interest, on all the browsers of interest, even if it requires a little additional thingy. And I also want to test early, right? I don't know if any of you are working with WebRTC. When Chrome 58 came out, everything went down because there was 4 critical bugs in it. And people only realized those critical bugs were here when it was in the stable release of Chrome, which made it even worse. Now you had to wait until Chrome 51, free releases cycle, to actually have the fix. And some people blame Chrome, but Chrome say, you know, we providing Canary development builds, nightly builds and things like that for you to test before. And if you catch the bug early before it raised stable, you never reach your customer. So that's also in the interest of the developer to test against Canary so that they find the bug before the customers that only use stable do, right? So you really, really want to go and test early. While originally, most of the people that were testing web application, they were more interested in, do my application work on an iPhone 4? Do my application work on that Android or Xiaomi phone that they have in China? So they were trying to test older release to make sure the website worked. Now we're speaking about testing early release. So the design is easy, divide and conquer. If you try to do everything at the same time, it's too difficult. So you're going to take care of the Selenium grid on one hand, the test engine on the other hand, and write the test separately. The test doesn't have to know about which browser is running on. The test engine doesn't have to know which test is running, you just need to distribute the test across all of them. And if you go that way, and you put some security in the code, because most of the time the problem is between the keyboard and the seat, you can actually achieve something nice. The conductor here is only taking a list of configuration, and his job is to check that the list of configuration are first exist. If you ask for Firefox 128, it's going to tell you you have to wait a few years for that to happen. Or it exists in the grid. I'm sorry, you're asking for Firefox 57 on Safari, and I don't have it accessible at the moment, even though it's a valid configuration of the browser. Then, once it has the clean list, it's creating the matrix and send it to the dispatcher. The dispatcher has actually a lot of artificial intelligence added, I would say. We put in the dispatcher all the things we could find about the difference in Selenium implementation. Selenium on Edge doesn't allow for the security prompt to be bypassed. Oops, Selenium on Safari, so the Safari driver can only do one browser at a time. So if you want to call a call between Safari and Safari, you need 2 computers. While with Chrome, you could get away with having only one because there is no limit to the number of browsers you can spawn on the machine. The small things like that make testing otherwise death by overwork have been hard-coded in the engine. And then the test runner just run the test synchronously. The test runner is here to make sure that the different instances of the test are synchronized with each other. The first one is going to click call, the second one is going to click answer. So it's synchronized, but it's not symmetric. And so that's what the test runner is dealing with for you. Long story short, you end up with very cute things like that, where you can actually request a certain number of configurations, Safari 10 on OS X 10.12, and so on, Firefox, Chrome, on different operating systems. It's creating the list of all the possible one-to-one call, running them for you, checking for time regression. Sometimes it keeps working, but it's 10 times slower. Customers don't like that. And it's giving you a nice interactive dashboard visualization widget for you to play with. And you can actually go for a lot of configurations. So you can make a lot of different runs with different number of configuration. And then you have an overview page that actually aggregates all the results for you if you want to impress your boss and say, look, you see absolutely nothing, but it looks great. Beyond the one-to-one call, which is not very funny nowadays anymore, everybody has been doing one-to-one call for 5 years now, we also have a multi-party version of it that uses Jitsi for the time being, but we're going to provide a version that tests against Janus, Curento, MediaSoup. Did I forget one from the slide before? No, I think I got them all. And so that's about it. So this project was sponsored by Google. It's fully open source and available for everybody to use on the GitHub address over there, which is the Google WebRTC GitHub. We are CoSMo Software.io based in Singapore, so if you want to ask us a question, our website is over there. And if you want more of those little tutorial introduction or purely technical news, you can either go to WebRTC by Dr. Alex, which is my own blog, or All Things RTC that Dan is going to present a little bit later. Thank you.
Thank you for speaking to the chat.
로렌조 다시 모시겠습니다. 이제 다시 가겠습니다.
Thank you, and thanks to Chris for fixing this issue for us. Okay, so I'm Lorenzo here. I'm going to talk about Janus today. First of all, thank you all for being here. Thanks to the organizer for having me here as well. As I was saying, I'm Lorenzo here. I come from Naples in Italy, in the south of Italy. I got my PhD there at the university some time ago, and now I'm in German and one of the co-founders of Mitico or Miteco or whatever you want to call it. I've seen it pronounced a ton of different ways. I believe a lot in open source and open standards, as you see in this presentation, and as you see from this picture, I should really try to cut this with this Viking kind of attitude. These are some of my contacts there. You can see also some of my previous slides on SlideShare if you're interested. So just a couple of words on Mitico. It started as an academic spin-off some years ago because, as I said, I took my PhD there and so did some of my colleagues. My tutor, my professor at the time, is also one of the co-founders of the company. And at the beginning, we were working a lot on conferencing, multimedia conferencing as part of the standardization effort, mostly as a research effort there. But then we decided to widen the scope a bit. So first we tried to bring what we were working on as a research effort to the market, and this is how Miteco was born. And then we tried to widen the scope to cover multimedia applications in general. And at the moment, as a company, we are doing several different activities. So most of our income comes from consulting activities. So companies come to us with a problem, they need our help in order to implement some applications based on Janus, maybe some custom plugins or stuff like this. But we also provide commercial support and Janus licenses in case they are needed. And also the streaming of live events. I'll say a couple of words about this here, because just as we've seen in the presentation by Jin-Ho, we really believe in using WebRTC for streaming in general events, pretty much like this event right here. And we've been doing this for a while for the ITF. So towards the end of the presentation, I'll also try and explain a bit how we do it here, and most importantly, what we did exactly last week, because I was in Singapore exactly for this. And we are proudly built in sunny Naples or Naples. This is a picture if you've never been there, so it's a nice place, come visit if you like. And in this picture, you can see both our office and my home somewhere. So I'll just let you guess where both are. And this is a nice picture instead of the collaboration that we as a company and CoSMo with Dr. Alex have been doing. I'll also go briefly through a couple of things that we've done together already. And this is a nice partnership because we actually do complement each other on the ways that we can actually provide WebRTC services, because our strength is mostly in the server side, they're very strong in the client side, and so during the last year or so, it became obvious that actually working together on some activities would actually be beneficial to both of us. So coming to the real focus of the presentation, I won't focus too much, of course, on WebRTC itself, but so you know pretty much how this thing works, people that want to communicate with each other and start exchanging information via a browser, via a web server of some sort in order to exchange information, signaling, negotiation information about the session they want to exchange, which eventually leads to a peer-to-peer communication with each other. So the server is not part of the communication anymore. The users just start exchanging media packets in a secure way between themselves. But the interesting thing about this kind of architecture for us has always been the fact that one of the two peers actually could be an application rather than an actual person. And this is actually very interesting for us because it opens the door to a lot of other things that you might do that might not be possible by just doing everything peer-to-peer as normal. And so if you think about some kind of a server that talks the WebRTC language, so knows all the protocols that are needed in order to exchange media with the user, knows how to exchange signaling information for this to happen, then there are several things that you can do. So you might implement some kind of an MCU where you have a mixer that actually receives contribution for everybody, mixes them together, and then sends the mix to the other participants. Or you might do something like an SFU where you just relay media around, so something that you might already do with peer-to-peer, but in a much more efficient way because you don't need to encode the same thing over and over. You don't need to transmit the same thing over and over. You just send it once, and then the server makes it possible to distribute media in a smarter way. Or even more importantly, you can actually do even crazier thing with this. So you might start interacting and involving other technologies that are not WebRTC compliant at all. So you might involve SIP infrastructures, RTSP infrastructures, or whatever kind of technology that existed before, RTMP, SerialLite, whatever. The idea is that if this server over here is smart enough and is capable enough to talk to these other technologies, then it is possible with this kind of an approach to actually allow WebRTC users to talk to all these other technologies transparently, thanks to this component over here. Which is actually what led us to start working on Janus in the first place. And so starting from why we chose Janus as a name for this, it's pretty much in line with the picture that you see over here. So Janus in the Roman mythology was the god of transitions. So he was a god that always had two faces, as you can see in this picture over here, and one was always looking at the past and one was always looking at the future. Pretty much the reason why January is called like this in English and in other languages. So January is the month that looks at the year that has just passed and looks at the year that is about to come. Which means that it was, let's say, an ideal name for the kind of component that we were trying to build. Because in our idea, WebRTC was the future and still is the future, and then you had all the legacy technologies that are still existing and are still important, and that you still want to take into account. And this is how we decided to then implement the component to make this all possible, which we call Janus, and which basically is an open source WebRTC server. And I say WebRTC server and not gateway, and this is written over there because actually a server is much more, let's say, descriptive of what Janus is strictly, because it is not just a gateway, you can do many more things with this, as I explained in a minute. And Janus is written completely in C, and this was done on purpose because we wanted something very lightweight that we could deploy from a Raspberry Pi to a cloud server or wherever we wanted it to be. And it's also completely open source. You can see the GitHub repo over there, so you are free to download it, play with it, install it, and do whatever you want. We have some the demos and documentation online as well if you want to play with it without installing it first. And also a very active community as a Google group if you want to just exchange ideas with the other Janus users to see what you can do with it. If you have trouble, you can contact the community and see if you can get this fixed. And so, sorry, wrong button. Coming to the architecture, we conceive Janus to be, considering the premises that I made, something that could actually do many more things than just an MSU, an SFU, or just talk, for instance, to the C world, but could do pretty much whatever we wanted. We conceived it as a modular architecture. So the core thing that was important for us was that Janus needed a WebRTC core, so something that could actually implement the WebRTC communication once without having to worry about rewriting everything from scratch every time you wanted to add a new use case or something. And so the Janus core actually takes care of all the WebRTC stack. So it takes care of the negotiation, the signaling, taking care of establishing the WebRTC channel, taking care of SRTP and so on, plus some other things related to some more advanced WebRTC features that you can see there. But then everything else is a module, it's a plugin basically. So you can see it as a shared object in Linux language. And so, for instance, we do have a Janus API, so a JSON-based protocol that you use to talk to Janus, to, let's say, to create sessions, to manage users and stuff like this. And this API you can transport over different protocols. So you can use HTTP, WebSockets, or other protocols. And if you want to use a different protocol to transport this API, you can do that because you just need to write a new transport module, a new plugin, and hook it to Janus, and it will just work. And in fact, as you can see, we have many of those depending on what the best approach for transporting this API is for you. But most importantly, the application logic is also implemented in different modules, and it's not hard-coded within Janus, which means that if you want to implement some kind of a web conference, or if you want to talk to the SIP infrastructures, or if you want to do just streaming, these are three different, very different requirements, very different features, and so they belong to three different plugins in our case. And so basically the idea is that all the logic, so everything that you want to do with the media streams is something that is implemented into this application logics over there. And so whenever you want to use a specific feature, you just take advantage of the feature that the related plugin exposes. And of course, this all works because the core takes care of WebRTC, so it's really not important if you end up talking to SIP, if you do a web conference, or if you do something else. WebRTC is already taken care of for you by Janus, and then in the back end you handle media the way you want. And of course, this allows you to do cool things because you can then combine multiple plugins together to do cool features and cool applications, and I'll show a couple of examples in a minute. But just to give you a clearer idea of how this works from an architecture perspective, you can see in this example that we have a user, in this case a browser, using the HTTP transport to talk to Janus. And then in this case it is creating two different peer connections. And we see two different colors over there because in the background the red peer connections is actually attached to this red plugin over here. And the green peer connections is attached to this green plugin over here instead. So from a user perspective, we really don't see any colors or anything like this. We just see peer connections, we just see media coming back and forth and so on. From the server perspective, you're actually handling these streams in a different way. So in this case, for instance, you may be interacting with a legacy protocol. This may be going to a SIP server for instance. And this other case, you're handling everything within Janus itself to do some cool things. And this is made possible, of course, by the fact that each of these plugins can also implement their own API as well. So I was saying that you use the Janus API to talk to Janus, so to create sessions and so on. But of course, each plugin, considering that each plugin implements its own application logic, also needs to have its own language to talk with users, which is exactly what we did. So you use the Janus API as a transport for the communication. So if, in case you are talking with the conferencing plugin, the SFU plugin, then you are going to use to send specific messages to that plugin to say, I want to join as this user, I want to subscribe to this other user, and things like this. If you are going to talk to the SIP plugin, you are just going to use a different protocol that is something that is more meaningful to the SIP world. Let's say, call this URI, accept this call, and things like this. And this is just a very simple example of how you can combine three different plugins to work together at the same time for a realistic use case. So in case you want to implement a webinar kind of application, you can use the SFU plugin to take care of the video and share screen, for instance. So you publish your own webcam, you publish your own screen using this, and then you may decide to use instead the audio or the SIP plugin to take care of the audio part. So For instance, you are using the C plugin to take care of the audio part, means that you can also involve the SDN users in the conversation, for instance, for questions and things like this. And at the same time, you may handle instant messaging using XMPP or doing a simple chat via data channels, which is something that Janus allows you to do with the text from plugin. And another cool use case is the typical social TV example. So you have a TV live broadcast, which can be a football match, for instance, which you might distribute using the streaming plugin that is our own broadcast kind of WebRTC broadcast kind of plugin. And then on the side you may have the SFU used to allow you to watch the match together with your friends wherever they are. In this case, you're using two different plugins which still do audio and video dynamically from a WebRTC perspective, but you're just generating the media in different ways and handling that in different ways as well. So just a couple of words on some of the things that we added recently. One of those are the event handlers that make monitoring and debugging much easier, because this allows a Janus instance to just generate events on the fly, both generated by the core and plugins themselves, and forward them to other applications. In this case, these other applications are still modules within Janus that can then handle these events somehow. So one simple case might be receiving these events, shooting them via HTTP to a different backend and have them handled somehow. And in this example over here, you see how these events are actually managed by the Hover platform in order to show, for instance, all the statistics related to a WebRTC connection handled by Janus. But this same approach is also what is used by codestats.io for their own Janus integration, for instance. I don't know if it's live yet, but it should be live in the upcoming weeks. We also added support for VPN simulcasting lately, which works nicely with both Chrome and Firefox. And VP9 has scalable video coding itself, which is one of the things that we actually implemented in partnership with CoSMo. And same thing for the support for Percolite. So Percolite is one of the newest things in the IETF standardization. We are trying to implement some kind of a double encryption, so that even if you do a video conference via WebRTC, and so media is going to a server, you are still ensuring that the media is encrypted end-to-end, so that the server cannot access the media that you are generating, but can only route it around. And so Percolite is one of the ways that are being suggested to do this, and we started implementing this because the CoSMo team, especially Alex and Sergio Samurillo, are among the people who are actually proposing this effort in the standardization environment, which means that it's always nice to have something running code to demonstrate that it actually works. And one of the other things that we have started working recently is a Janus Lua plugin, because as I anticipated before, Janus is written in C, which means that if you want to write your own plugin to handle media your own way, you need to implement your plugin in C, so you need to be able to code in C, which is not always easy, of course. And so to make things easier, we started writing this so-called Janus Lua plugin, which of course is still a C plugin at the core, so it still takes care of the media manipulation for you in C and so on, but exposes all the information as Lua functions, so that you can write your own Lua scripts to then dictate how to manipulate the media and so on. So in this screenshot there, you can see our own example of how to implement the echo test, an echo test kind of application in Lua. So just handling new users, making sure that whatever they send is sent back to you, sent back to them, and so on. But we also have a simple conferencing application written in Lua. And ideally, this will make it even easier for people to write their own applications and so on, even focusing on how the media is handled within Janus itself, and not only from an application control perspective. Of course, all I've said so far is nice and all, but there are some considerations that need to be made with respect to scaling, because of course scaling applications, and especially media applications, is always hard, but it's typically made easier when the context is well defined. So you know that a media conference works in a specific way and how you can scale that. You know how a WebRTC broadcast works and how you can scale that. With Janus, this becomes a bit harder because, as we've seen, we have tons of different plugins that can handle media in different ways, and you can actually combine these plugins in different ways. Which means that scaling Janus becomes a bit of a challenge, especially when you start to involve multiple plugins and so on. Which means that you need to be very aware of the context that you are implementing these applications in, how they are using the plugins, and how to actually distribute the media so that you can actually scale the application to handle 100, 1,000, 1 million users and stuff like this. And of course, there are the typical approaches usually work depending on the context. So you might do some kind of a load balancing if the streams are pretty much independent of each other, or you might do some kind of a brokering of resources, for instance, in the case of a conference, by distributing different conferences on different services and letting some kind of a broker decide where you actually have to go and so on. But actually, a more interesting idea is taking advantage of the so-called RTP forwarders, which is one of the things that we added some time ago in Janus, which are really simple as a concept. So some plugins have the ability to forward the RTP stream that the RTP streams that the WebRTC users is sending to another endpoint via plain RTP, which means that once you have successfully injected WebRTC media towards Janus, then there's no limit to what you can do with this media, so you can just forward it around to do other things and so on. And in the simplest example, you can imagine some kind of a tree topology to implement WebRTC broadcasting in a more efficient way and distribute a WebRTC media to a ton of different participants. What you might do is, let's say, having Janus here at the head of this distribution tree to inject the media. So imagine this user is injecting his own media for distribution. Then you use the RTP forwarders to start distributing this to one or multiple media relays. These relays then trickle down the media up to a battery of other Janus nodes that are just actually acting as edge nodes, so that all of these participants here, no matter where they join, can actually receive the same media that was originated at the very edge over there. And of course, this opens tons of different opportunities, because the same thing could be done also to allow to expand the way that WebRTC conferences can be done, because you can distribute rooms around, you can take advantage of geographic distributions of users and so on. So there are several cool things that could be done, and we are experimenting with this in these very days. So, and I'm almost done. So you may be wondering who is actually using Janus today, and of course we started writing Janus because we needed it ourselves, and I'll explain a very specific use case in a second. But there are people that are actually using Janus in tons of different ways nowadays, and I'll show you a few examples in a minute. So ranging, so not very specific scenarios, but really a broad range of scenarios that goes from more traditional things like conferencing, learning, and so on, to video game streaming involving drones, installing on Raspberry Pis, Internet of Things, and stuff like this. And there are people are also starting to contribute back with Janus with interesting resources. So people are starting to write their own plugins or their own ways of controlling Janus, so their own stacks to actually implement the Janus client API, let's say in .NET or in whatever language they are more comfortable with, to control Janus not from a browser but from a server, let's say. And I was saying that we're using Janus ourselves a lot, and one of the biggest use cases that we use it for is, of course, streaming the events that we provide support for. One of the more important ones is, of course, the ITF. And I was in Singapore last week, just yesterday actually, to stream the ITF that has ended just today. And in this case, you can see this is a screenshot of the distribution of the RTC Web meeting group that was held, I think, a couple of days ago. And so, from an application perspective, it looks exactly like the typical conferencing application that you may be familiar with. So, a chat room, the slides over there, and a couple of videos showing people around. But of course, behind the curtains, considering that it is an event, it is a bit more complicated than that, because we need to take care of capturing the local video via some webcams, pretty much like we're doing today, and capturing the feed of the beamer as well, of the projector, so that you can turn this into a WebRTC broadcast at the same time, capturing the audio from a mixer that is actually sitting in the back of the room and that is taking care of all the microphones in the mic blinds and on the chair desk and so on, and making sure that all of those streams are injected in the virtual room, while still allowing remote participants like Kranky Jennings in this case to actually still chime in and make questions from their home, present remotely and stuff like this. And without going into much details, this actually involves 3 different Janus plugins at the same time, because we use the sync plugin for audio, we use the streaming plugin for these parts over here, because we do not capture these 2 streams via WebRTC via browser. We use simply Raspberry Pis with an FFmpeg that capture those feeds. Those are sent to Janus, and then they are turned into WebRTC broadcasts by Janus. While all the WebRTC remote participants are actually using the SFU plugin. And so once you make these streams available in the web application, there are, of course, you can do with them pretty much whatever you usually do with web applications. So playing a bit with the layout, so focusing on some streams rather than others whenever the context allows for it. So showing them together, hiding some of the streams when they are not needed. Like in this case, the discussion was more important than the slides, so we could hide that as well, and so on. And of course, still allowing for multiple people to communicate with each other at the same time. In this case, there was a remote presenter and a remote speaker on the chat on Firefox that were communicating with each other and the mic line in the local room as well. And all of those streams are recorded, so we can record them, each stream individually, we then post-process them and mix them together and upload them over YouTube, while still keeping also a history of the Jabber room so that you can watch it into a synchronized way at the end of every meeting. And this is a screenshot from the 60th working group that happened this week, because we typically upload these recordings at the end of each day. And this kind of approach was also very helpful for us, also from a control perspective, because the ITF is a big event. It lasts 5 days and it has 8 separate tracks at the same time, which means that you have to control and monitor 8 different rooms, so 8 different cameras, 8 different projectors at the same time. We're a small team and we cannot possibly be in every room at the same time. So what we can do is take advantage of the fact that all of those streams are handled by Janus, and then implement a different controlling application that allows us to watch all the streams, control them, follow the speaker when they move around and so on, and also be aware whenever there is a problem. So if a camera stops working, we can see it right away, we can run to the room and fix it, and things like this. So it allows us to control the recording process. It has made our life much easier, let's say. But you may be, I'm sorry, these are a couple of links if you are interested in learning more about how this works, because of course I cannot go into much detail, but I have the slides of a complete description of how this all works on SlideShare, and there is also a video on the VoIP Users Conference portal that also has a video about 1.5 hours, 2 hours of me talking exactly about this in detail. So explaining how we interact with the local mixer, how we deploy cameras and things like this. So feel free to have a look if you're interested. Now, coming to how people, other companies are actually using Janus, there are several different use cases which are really very important for us because they show and demonstrate the flexibility of Janus as a component. And the first example that I'm showing here is from Skyway. Skyway is a part of NTT from Japan, and they're using Janus for their Internet of Things functionality, so as part of the Skyway IoT SDK. And they also wrote their own Janus plugin for the purpose, so for handling both the media streams and the data channels over there in the way that they really need it. So, and this was really important for us as a use case, as an example, because it proved that actually people could actually tailor the Janus exactly to their own needs. Of course, Slack is a big example. They were among the first big adapters of Janus, and so we were really excited when we found out that they were using Janus for their own infrastructure. And they presented at Kranky Geek a couple of weeks ago, where we found out that they are using, let's say, a very old fork right now. So if you excuse this idiot picture that I just find funny. But I mean, they forked Janus a couple of years ago, and so they are lacking many of the features that we made available since. But it's still a very important and relevant use case for us because it was, again, one of the first first use cases of Janus being used by a very large company for very large use cases, which was and still is very important for us. Mattermost is what many people call an open source alternative to Slack, and they also, interestingly enough, chose Janus as part of to implement the same kind of functionality in their platform. TokTV is an interesting use case because it's basically a sports social network and has partnerships with soccer clubs like Real Madrid, Barcelona, and things like this. And it's basically a mobile application that allows you to communicate with your friends and talk about the match while you're watching it and so on. And they recently became very popular in China because they launched the application there as well, which is kind of interesting. And they are using Janus as the backend for all the interaction with users, so being happy with your friends, shaking the phone to send your video, being happy, and things like this. And this is quite recent news, so we got in touch with Services because they are interested in, you may know Services as the providers of turn servers and stuff like this, but they're actually more interested in becoming a more generic RTC server infrastructure. And so they are playing a bit with different RTC server applications, so not only ours, of course, but also with others. And ours might be a good use case to demonstrate how you can actually scale Janus on a very big infrastructures like theirs in order to build complex applications. And so it's actually very tied to the slides that I showed you before about how to scale Janus effectively. So we will probably talk with them in order to try and demonstrate how you can scale different Janus applications this way. Lenovo also has an interesting e-learning application that also uses Janus as its backend. There is CoSMo that is using it for its click-to-box functionality, which was also kind of cool. Composo is a contact center provider. They basically remotize contact server functionality so that you can have your company have contact servers, agents, wherever they are, and just use WebRTC to have them communicate with customers and so on. Beating is a web conferencing, white label conferencing provider, and they also use Janus for their functionality, mostly for both for SQ and SIP needs. Evercast is also an interesting use case because they are using Janus for a new functionality, so not strictly related to just communication, but also media production. So this is something that I'm looking forward to see how this will turn out. And a couple of use cases that are more focused, more related to the open source environment, but that I still mention because they were there from the very beginning and so are quite important for us. One of them is Hangouts, which is basically a clash of the terms Janus and Hangouts. So these are open source developers that wanted to have their own Hangouts kind of application, but based on open source technology. So they choose Janus for the purpose, coined this nice name that I really love, and then based everything on top of Janus. So everything, audio, video, chat via data channels is implemented using Janus as a backend, which is a really interesting use case for us. And then there is Geek server, which also contributed a lot to Janus as a product. So they contributed a lot of code, which is a XMPP application server, which also has mobile applications that allow you to communicate via their infrastructure. And last but not least, video game streaming is something that is actually becoming very, very important lately, and this is a really hot topic in the broadcasting scenario because people are starting to look into WebRTC to decrease latency, as we've seen in the latest presentations and so on. And there are actually many companies that are starting to use Janus for the purpose. One of them is Microsoft because they acquired Beam that was using us at the time. And Beam has since turned into Mixer and they are still using Janus for this distribution, which is, of course, just as with Slack, it was a big deal for us when we found out because it is a really huge case and knowing that Janus can serve it is actually cool. There's Bebo or Bebo, which is also an interesting approach because they don't use Janus as a distribution server, but they use it as an injection kind of way. So they use WebRTC to inject streams that then are sent to platforms like Twitch and so on. And then, of course, there is Evasyst for these. I will not delve too much on this because, of course, we have Jordan here. We will go into details about explaining how exactly it works, but they are also using Janus in the backend, which really excites us. So this is pretty much it. Of course, there are some things that you still need to do. The Janus already works nicely as it is, but there are a couple of things that we might want to improve. Most importantly, we currently lack support for the unified plan, which is something that we'd like to solve soon. And I already mentioned the Lua plugin, but what's interesting in this is that Lua has already proven that it can help make life easier for plugin developers. And so we started thinking, why not expand this Lua plugin in order to cover other programming languages as well, so that JavaScript developers can write their own plugin, Tcl or Python developers may do the same thing, and so on. Considering that most of the meat of the plugin is there in the C code, it's just a matter of making sure that the same functionality are available to other programming languages as well, and it should just work in theory. And of course, we want to continue the development of ad hoc scaling solutions for Janus, because the use cases and applications are all there. We just want to make sure that scaling is as easy as we think it might be. But of course, I'm here mostly to make sure that people that were not aware of Janus or that may just have heard of it were actually more interested in this. And so I hope that this presentation was interesting enough for you all and that this will convince you in giving it a try. So I encourage you to just go on the GitHub repo, just have a look at the demos, download the software, start playing with it, start creating your own application. Think if you have any crazy ideas that you had in mind that you could not solve before that Janus may help you on. I'd be really excited to help on that. And I guess this is all. I hope I didn't take much of your time away. If you have questions, feel free to ask them. Thank you.
to start. See, here's the thing. All right! Wake everyone up again. All right, that's probably the biggest excitement right there. I'm Dan Burnett. I'm going to talk about a new project that I have going on. But first, a little bit of background. So my background is actually in computer speech recognition. That's what my degree is in. And I've been working on a number of standards. I actually started at Nuance, which is a well-known speech recognition company. And while doing that, I worked on voice XML in W3C, and that's how I got involved in standards there. As you can see, I've worked on quite a number of standards, including WebRTC. So I am the original and longest running editor of the WebRTC specification, and also the media capture and stream specification. Anyway, I do a lot of standard stuff, and this is my book. Actually, we have it in English, Chinese, and Japanese, but not in Korean yet. Okay? So we just need someone who's interested in translating and publishing in Korea. We're happy to have it published here as well. This book was co-written with Alan Johnston, who is one of the authors of SIP, and who wrote the SIP Handbook Reference Book. For anyone who does SIP programming, you probably have his book on your desk. So the two of us wrote this WebRTC book, and we will update it as soon as WebRTC stabilizes a little bit more in implementations. And we're all waiting for that. Okay, so what am I going to talk about now? So this really comes down to, what is life for you like if you are new to WebRTC? So life is pretty good. There's a lot of good information out there, right? WebRTC Hacks is a great blog. Google's WebRTC project site is very good. In the US, there was a WebRTC Expo conference that's now called Real-Time Web Solutions. Obviously, Kranky Geek, thanks to Chris, where'd he go? There it is. All right. We'll be talking later. Sahi has a fabulous blog with lots of great information and has for years. So there's a lot of good stuff here. But every time I present at a conference, every time I speak with a group, I hear the same complaints. Information is scattered on the web. Much of the information is either just a referral to somebody, or it is put on by some company that has too much of a corporate spin. And it's a continual frustration. People who are starting know they need to come up to speed rapidly on the technology and on the players in it, but I hear over and over again, yes, but I can't get past the marketing information to just get the answers that I need. So it's really important that they have an unbiased perspective that is focused on them. So the real-time communications industry, I believe, needs a new voice, and it's important for that voice to be unbiased. And to quote Mario Draghi, the president of European Central Bank, in 2012, actually I'm stealing his quote, to say that we are ready to do whatever it takes, and believe me, it will be enough. I am independent. I am not beholden to anybody. I am no longer an employee of any WebRTC company. Okay? So, I have a site now, allthingsrtc.org. And we'll just look at it briefly. Hey, I didn't get the mic. Are you getting any of the recording?
I just realized maybe you have absolutely none of what I just said on the recording. Excellent. Okay. That's a little small. Please. Thank you. Okay, so I'm just going to go very briefly through this. We have a set of articles which today are mainly interviews that I've been doing with experts. You'll see a number up here, including Alex, Lorenzo. His video is going to show up any moment now. We're doing a final review of it, but it's been recorded. And there was an interesting discussion in W3C and IATF last week about potential interactions between Koehncke and WebRTC. So my goal here is to capture the information from experts. This is not me interviewing them to get 2 lines of information. This is me asking them, in their words, why what they do is important. This is something that I believe technical product managers, product owners need in order to make their decisions. So these are the articles and interviews. We're going to have, well, we do have some news links as well. There is a place for telling us what you want. So if you do not see something on the site that you want, not that slow, you can request something, and we will do our best to provide it. Okay, the ideas that are popular here. We have a providers directory which is growing, and we also keep track of events. And by the way, the providers directory, no one paid to be on this list. Okay, these are just providers who are in the real-time communications space, not just WebRTC, but any real-time communications provider. As we come across a name in an interview or an article, we're going to do our best to get it up in the provider list. Kranky Geek is done now, but I still have this up for probably another week or 2. As events happen, we're going to put them up here. If you have an event in Korea and you would like it on this site, let me know, okay? And I'm happy to put it on there. And you know, generic glossary. This is growing fast, and so pretty soon we'll need some kind of index to find words. But again, people don't know what congestion control is, right? But you have to know what that topic is to understand some of your decisions for WebRTC. Okay, so who is this for? So for those of you who are programmers and building applications using WebRTC or any other real-time communications product, it's essentially your boss. It's the one who usually is not coding, but the one who has to make a technology decision. Why do we go this direction rather than this direction? That's who we're aiming at. Now there's a lot of information that's relevant for developers as well. So we definitely have a very strong developer focus. So it's basically for anyone who does not have time to sift through tons of partial blog posts to get information. I'm trying to get the most important info as quickly as possible, and ideally without a lot of marketing bias. So what are we trying to do? We focus on what matters, and we do that by helping experts tell their stories. So who is an expert? Okay, obviously there are people who know about Koehncke and WebRTC because they are building it. They are the ones designing it. At the IATF, I have a number of people I spoke with who will probably be talking with me pretty soon about some of the new work happening there. It's also people who do something new and interesting, like Dr. Alex. The WebRTC industry needed a testing framework. It was crucial, and no one had solved it in quite the way he did. So I wanted to interview him because it matters for everyone in the industry. So if you have a product that's doing something new and different, I want to hear about it. Okay, and I'll just be blunt. It doesn't just mean that you have now added WebRTC onto your unified communications platform, because everybody does that. Okay, if you have something else, novel and different, let me know. So we don't accept things that look like articles, but actually are big advertisements. There's an awful lot of articles out there that are like that, and we turn down many articles. We are, however, happy to point to anyone who provides something of use, whether it's a product or an information or service. I have people who say, well, you're a competitor to me. No, actually, I am happy to point to any other site like this. All of the other sites I mentioned, I'm happy to tell you about them. What we want to do is get somebody who needs information to the right place for that information. Okay, no funding conflicts. I'm independent. I'm going to work very hard to keep it that way. That doesn't mean we don't have sponsors, but it does mean that I don't let the sponsors bias the content. Okay? The goal is to build a community, and this is not a side project for me. This is not something that it's just me doing. I have staff, and the amount of work that the staff is doing is growing, and the staff is growing to do this. The news links we have are actually real news. They're either new technology or feature announcements, novel deployments. They are in general not customer wins. Okay, customer wins, yes, they're nice from a business perspective, but we found that most people already know about the customer wins from that company's website. They don't need to get it here. Okay, so there are some things that we are planning for the future in this coming year. One is translation. So we are already planning to translate at least some of the articles into Chinese, potentially Japanese. If there is anyone interested in helping us translate into Korean, we are happy to do that as well. We will probably start doing some focused, I'm going to call it a meetup for now, focused gatherings, but again, it's to help people make proper decisions with respect to real-time communications. We're going to need help with some getting started guides. Everyone needs a beginning. What is WebRTC? What are the things you need to think about when you're considering WebRTC? Maybe it doesn't give you all the answers, but it tells you if you're not thinking about signaling, you're missing something very important. And oh, by the way, that's where identity lives. Any kind of identity system lives in your signaling layer. People may not think about that. They may not think about churn servers and how they're going to have to deploy those. So we aren't necessarily trying to get answers there, but we are trying to make sure that people know what the topics are that are going to be important to them. And then we'll have more focused guides as well. So if you are interested in helping with that, that would be great. And eventually we will have some community forums as well. So one of the other things that we are doing is an industry technology and capabilities survey. So if you want to know who's doing what, give me your contact info and I will notify you when it's ready. Okay, so we need you. We need your help. So this is not a presentation like everyone else's that tells you something new about WebRTC. This is me asking you for help. You are the experts. You are the people doing the interesting things. If you are creating new technology, if you are implementing applications doing interesting things, then I want to talk with you. Please come contact me. Do not send your marketing folks to me because I will send them away. Okay? That's not what developers want, and that's not what business decision makers, technology business decision makers do. We will be taking sponsors. I don't know if you noticed, probably not, on my site. The only advertisement on there right now is for my book. Okay, I'm not trying to sell my book. That was just because it's a placeholder for ads. Eventually, my book is probably not even going to show up very much on there. So we will be taking sponsors. We're working up sponsorship packages and would like to know what would be of value to you or your company. The sponsorship goes to supporting those of us who are actually building the site. Okay, that is what it's for, exclusively. Initially, I just said me and my staff. As we have events, some of the money may go towards the events as well. So you can contribute content in terms of articles or use cases, help with the getting started guides, or let me interview you. We are considering having a guest blog opportunity. So this would be, for example, we might actually for Korea, if there's someone who would like to write a blog that actually describes things that are happening in Korea, that would be great. Or Seoul specifically, it doesn't matter. I'm still open. We're trying to figure out what it is we need to do here. Okay? And of course, participating in events. I showed you how you could request information on the site itself as well. So specifically on sponsorship, we intend to be a global voice for the community by the community. And that means you will have a global reach if you sponsor. You can actually do local sponsorships as well. So as we do events, we will be looking for local sponsors. Again, the goal is to keep it useful for the people coming because that's what matters for all of us. Thank you.
Hello. Thanks, guys. I'm Jordan. I'm with the CTO of Evasyst, and we are based in Irvine, California. And I'm really excited to be here in Korea talking to you tonight because our company was started around the concept of esports, and I know that South Korea is the capital of esports in the world and its birthplace. So really super excited to be here. I'm sure you guys already know a lot about esports, given that it is basically a national sport here in South Korea. As you're aware, it's an extremely fast-growing market, and competitive gameplay consistently represents a new vertical for traditional competitive sports media. So in the United States, for example, we have ESPN, which is losing a lot of viewers on its traditional sports network, but now they're starting to do content in esports. There's also professional sports franchises all over the world that are trying to do outreach to new millennials who don't traditionally watch as much of the traditional sports, soccer, American football, baseball, and so they're investing money in buying into esports leagues and teams to promote new audiences. Collegiate sports programs are also offering scholarships. Our office is based on the University of California, Irvine's campus, and they have one of the biggest investments in the world in esports at the collegiate level, opening their esports arena just last fall. And it's really a market that grew out of online streaming, so broadcast over IP. It wasn't real traditional radio broadcast and that sort of thing, because it's only come around in the last 5 years or so. So the problem definition that we sort of figured out when we were working with gamers was that we saw that a lot of gamers were sort of bootstrapping this experience of sharing their screens amongst themselves using Skype or Hangouts. These are products that are traditionally used for video calling, and screen sharing was sort of an afterthought when they started to implement these features in their products. And so there's open source tools like Open Broadcaster. There's also some paid tools like XSplit's Gamecaster, and then the solutions coming from the hardware manufacturers. And in the United States and worldwide, one of the biggest websites to launch for these was Twitch. And these are still using Flash technologies. Here in South Korea, I think you have Azubu. China, you have Dota, or not Dota, Banners TV, Douyu, if I pronounced correctly. And in addition to using these experiences in their computers, they were also using older technology over VoIP, Mumble, Ventrilo, TeamSpeak to basically enhance their gaming experience where they're playing together online, but it's a mouse lock game, it's the entire screen is filled up, and they want to collaborate with their teammates, and so they're talking to each other over voice. They're also consuming content on their additional devices and monitors at the same time they're sharing their screens with their users. So, coming back to how we decided to go about this, we wanted to build desktop software because video games are one or 3D games in the PC market are one of the few things that users are still really installing as desktop software. It's a product that you typically have to download and install on your computer, whereas pretty much all other consumer products today seem to go through a website or a web browser. So as an engineer, there's a couple different solutions that are possible to get access to building desktop software. One of them being Electron, which is a component of combining the Chromium web browser and JavaScript and HTML, CSS rendering engine. And then there's also React Native, Xamarin from Microsoft, and Qt. And we ended up going with Qt down there at the bottom because it is one of those platforms that is very human-machine interface oriented, so you don't have to launch a web browser. And what we really wanted to do was combine the things that users were doing in their web browsers, Mumble, Ventrilo, TeamSpeak, into a single application that you could install on a desktop. And this also sort of brought us to another problem that we had at the time, which is that, you know, when you're working with desktop software, well, let me talk a little bit about how you create games first. So building games is typically using a game engine. There's three big ones that are open source, the CryEngine, Unreal Engine, and Unity. And these are kind of interesting in the sense that they are free to use. There's developer seed models, but at the same time, if you want to use them for commercial purposes, they have some pretty interesting licenses built into them. So, and there's also a lot of really specific language about building games that involve gambling. which I thought was kind of interesting. And the other thing is that you have to go back and then actually pay them a bigger licensing fee if you want to use one of their engines to produce your game, if you're going to use it for gambling. Or in the case of CryEngine, which was kind of funny to me, they specifically prohibit you from creating serious games, which I don't really know what that means. I guess you can make games that are not serious, and they will decide whether it's serious or not, or you have to pay them a big licensing fee. And the other thing about these streaming engines that's kind of interesting is there's been this concept of another relationship between video and gaming, which is cloud gaming. And so before we get to that, there's sort of these new intermediary services that have come about in the last few years. And these are sort of the go-betweens of the game producers and the users. So these are like Steam or Lumberyard that allow game developers to do things like microtransactions, authentications, achievements, and then also Amazon's Lumberyard, which is a relatively new product for them, which allows them to embed a CryEngine license without a lot of the onerous provisions, and they sort of have this add-on utility to build widgets for Twitch and that sort of thing after they acquired Twitch a couple of years ago. But coming back to cloud gaming, so this is one of the biggest interesting areas of video streaming for gaming-related content, and this is basically the concept of having a game rendered in the cloud at a data center somewhere and then sent back to the user. So as they're playing the game, their controls are being sent over the wire to a data center, the frames are being rendered and sent down to the user so that they can play these 3D games that typically require you to have a pretty strong graphics card in your system on like a thin client, like a television or a tablet, something that doesn't have as strong of a graphics processing unit. And you know, looking at the way that these products were built in relation to video is that one thing that interested me a lot that couldn't really wrap our heads around was they were still using RTSP and X264, which is technology that's been around probably since the 90s. And the sense of this is that, well, RTSP is fast enough, you have to have a lot of infrastructure in place. So the mechanics are not quite there, the economics are not quite there for cloud gaming, in the sense that you have to be one of these big players like Sony, NVIDIA, Liquid Sky, OnLive, that allow them to deploy the infrastructure to get that latency down to enough that you can actually render the game in the cloud and then get it back to the user so that it doesn't feel laggy. When you press a key on the keyboard, you expect the character to move. If you have a graphics card locally, that can happen 10 to 15 milliseconds. It's almost unnoticeable. But when you're trying to send something over the wire, it takes a few hundred milliseconds, and then it becomes laggy in your perception. There's also some other cloud gaming-esque devices. These are like streaming devices, and they allow you to stream high-quality content from your graphical processing unit that's maybe on your PC to your thin client TV. So the big advantage here is that you're over a local area network, so you can do pretty high-quality video locally, and there's not really a concern about the latency because you're on a local area network with next to no packet loss. So as a result, again, they use RTSP and X264, and that's because X264 encoding is really prevalent in hardware acceleration, and it's a consistent quality of video, but the problem is you can only do the highest quality video locally. And so when we set out to build our product, we really wanted to build something that would create a competitive advantage for gamers, in the sense that we wanted gamers to be able to, either with their teammates or their coaches or analysts, be able to see their gameplay in near real time, either while they were playing a competitive match. As you guys know, esports is very competitive. There's a lot of money on the line, and so it's very important that they be aware of these situations so that they can do the best call-outs possible. But this situation with RTSP and X264 just wasn't cutting it, because streaming over the internet created a delay, and then you also had users who were on Wi-Fi, and then you had issues with bandwidth management and everything like that. And And coming back to that cloud gaming response delay, which is a similar issue that we have with our users, is the sense that you have the time that it takes to both process the input from the user, the time that it takes to decode a frame and also render a frame. Then you have network delay, which is the time that it takes. So if you're looking at a traditional game that is about 30 frames a second, you only have a few milliseconds basically before the next frame has to be updated. And most of these games are rendering at a few hundred frames per second. So no matter what you do, whether you're capturing at 30 or 60 FPS, you still are only capturing a small component of the number of details that are actually being rendered on the screen. And add that to the typical TCP delay, you have a lot of issues. So in this space, as Lorenzo mentioned earlier, we saw that Beam and Microsoft had gotten involved with WebRTC again around the same time we were getting started, and it was interesting to us because they were able to cut the latency that they were streaming to a few hundred milliseconds, which was very interesting because everything else we had seen on the market, whether it was Twitch or Zoom or anything like that with the flash services, there was a 10 to 20 second delay. So basically you could bootstrap this experience with your friends, but if you were watching them play on Twitch, there would still be a 15 to 20 second delay, so it didn't really create a competitive advantage for you. So this is what really gave us the entrance into WebRTC and looking at it. And this is where we started to encounter, the real challenge that we face in getting WebRTC into a native desktop environment without a web browser. So, when most people that I talk to, developers I talk to, think about WebRTC, they think about a web browser, and they think that it only lives inside of the web browser. And really, what I've learned in the last year is that's not the case. It's a specification, and it's typically implemented by a browser manufacturer. But it doesn't mean that it has to live inside of the web browser. But that was sort of a long haul talk to figure out, calling people, asking enterprise software salespeople, the kinds of things that Dan was talking about earlier, where you sort of hit a brick wall of understanding, where you try and call someone to talk to them about WebRTC as a developer, and they say, oh, we have an enterprise conferencing product for you. Say, I need something, a lot simpler than that, a lot more low level than that. And then you would call it developers. They would say, I know everything there is to know about WebRTC. You fire up your JavaScript web engine, and you write a few lines of JavaScript, and you're good to go. And that really was, and then I would say, okay, well, that's great, but I don't have a web browser. I'm building desktop software. So, and then it was just crickets. So, there was the crickets I was hearing before I met Dr. Alex. So we knew that there was a big implementation inside of Chromium, and that it was open source, but it was built inside of Chrome. So Chrome is a great web browser, but it is a big giant monster as far as software goes, and it's very hard to figure out, what's up or down, especially as someone who's trying to approach just one component of the web browser. You're not trying to assemble the entire thing for your own use. You're just trying to assemble one piece of it. So what we started to do, and what we've been doing over the last year with Dr. Alex, is basically to compile WebRTC as a standalone library that's able to be used with native C++ software. And the advantage of doing this is that you don't necessarily have to have a web browser to access the APIs in WebRTC, get the low latency video streaming, the bandwidth management, all of the things that WebRTC does really well, that some of these cloud gaming companies have invested millions of dollars into creating proprietary solutions for. Now, this wasn't without its difficulties. The money that's being invested in developing WebRTC protocol implementations by the web browser is there to serve their own ends. They want to include WebRTC for creating products like Duo and Hangouts, and those are great products, but they're not in the business of creating a standalone broad library. And And so that's what we really needed. And with a lot of sweat and tears, we were able to finally pull WebRTC out of Chromium, make it a standalone library, and really start to stand on top of it in terms of creating a C++ application, which is really great because it has the ability for us to do things that maybe we don't have to sit around and wait for the browser manufacturers to do. So this is implementing new codecs, maybe deploying onto embedded technology, and also porting to, say, a gaming console where you might not have the full-on latest web browser, and also interface with the developer community like you guys, which is really exciting for me, and also go back and forth between mobile and desktop relatively fluidly, because at the end of the day, a lot of this stuff all boils down to C++. That's what it's made out of, and so as a result, it should be accessible to other C++ code, not just JavaScript. So, now that we've been able to do this with WebRTC and create this module library, we're interested in expanding more of the areas that people have taken interest in real-time communications as they relate to gaming and video distribution. There's a lot of companies that are doing peer-to-peer CDN acceleration with WebRTC, which I think is pretty cool. The audiences for esports are off the charts, especially here in Asia, and there are certainly countries and areas that do not have the sort of bandwidth penetration we have here in South Korea, but there's still a big audience for esports. And so as a result, I think there's a big opportunity there for peer-to-peer CDN accelerated models. There's also developers out there who are interested in using WebRTC's data channels to do peer-to-peer TIC servers, which is a component of multiplayer games that uses UDP and could benefit from a peer-to-peer model. And then, ultimately, maybe there's an opportunity in the next 10 years here to implement, real true cloud gaming and get it out there with the type of technology that's being developed around WebRTC. And a little bit about Evasyst. We were founded in 2015. We're a member of a business incubator similar to this one in Southern California. And we've interfaced with a lot of really cool developers around the world: Hong Kong, Finland, Singapore, where we just were last week. And we have partnered up with various collegiate esports programs across the United States, as well as some professional teams. And if any of you know anything about the esports scene here in South Korea, I'd love to talk to you after this and hear more about it. And then just here's a couple screenshots of our project. Thanks, guys.
Okay. Oh, wow, look at the technology. I like the little I did not fix the video. The other gentleman fixed the video. I just made it seem like I fixed the video. So I'm the last presenter. Thanks for coming out and hanging in tonight after our technical problems. I'm Koehncke, and I am part of the Kranky Geek. And I've been working with Google for now 4 or 5 years on WebRTC. Part of Google's mission was to make WebRTC easy to access for the developer. We've had a lot of technical talks, all sorts of technical stuff. What Google was after was to make WebRTC as a communications path very easy for any developer to access and build a communications app. I have built a WebRTC app myself. Thank you. Oh, thank you very much. Yes. And so we've been doing this event at Google. We have a lot of fun. This is actually the Google. I'm very proud of my Kranky Geek drinks now. We have Kranky Geek drinks. And I work for TokBox, which is a WebRTC company, but we won't focus a lot on them. You can play with their demo if you'd like. Open Talk demo at TokBox.com if you want to see a quick WebRTC demo. We also have I'm going to give you a summary of what happened at Kranky Geek. So Kranky Geek was held at Google in San Francisco 2 weeks ago, and we had a record crowd, our largest crowd ever, and a whole bunch of companies speaking. So here's a whole bunch of companies speaking, And here's the YouTube playlist that you can go back and listen to. But I'm going to give you a summary of kind of everything that happened. So let me start with the easy piece. Google is mostly done with WebRTC. Oh my God, really? They're kind of moving on because WebRTC works. It works. Now there's some minor problems that they're still working with. We'll talk about that. But a lot of the things they're interested in, by the way, if you haven't downloaded this Kiwoo, hello Kiwoo, Kiwoo, my friend right here, he discovered this is Microsoft Lens running here. One of the things that's happening is WebRTC is intersecting with all sorts of new technology in the area of real-time communication. So the hot topic is machine learning and artificial intelligence, and I'm going to let you on into a couple of secrets with what Google is working on, because they won't tell you, but I know what they're doing. They hate it, but I know. The other thing is also image recognition, and this is Blipper. Blipper is really cool. It's an app you should download and play with it. This is our office in San Francisco. So Blipper is doing image recognition, things like emotional detection, natural language processing, sort of transcripting. All is intersecting very quickly with WebRTC. So there's a lot of very interesting new things that are happening, not WebRTC specific, but related to real-time communications where WebRTC intersects with that. Now I'm going to go through what Google talked about. It's extremely boring because it's not very exciting. This is Google's plan for 2018. So they're worried about being in line with all specifications. They want to be compliant. They're testing it in 6,000 different ways. Their big thing is they want it to work. It sounds simple, but it's hard, because if a new user tries something and it doesn't work, then they go, oh, this doesn't work. And so it's very important for them to make it work. And so there are lots of little problems they're still working on, lots of little glitches, audio issues, little minor things, but they want to make sure it works all the time, everywhere. So not terribly exciting, but kind of key for the people working on WebRTC to continue working on this. For a good example is this is, since 2012, there's been a problem with the Macintosh computer, the MacBook. Periodically, WebRTC would just stop working. Not a lot, every now and then. No one knew why. They didn't really care. But it didn't work. And so finally, one engineer at Google got mad at this and said, I'm going to go figure out why this is breaking. And it took a long time for them to figure it out, but this engineer has now figured it out, and it's now rolled into Chrome, so that if you're on a MacBook, suddenly WebRTC works a little bit better. There's also a lot of work around audio echo cancellation. Really, really boring echo cancellation. But if you've ever experienced it, it's very, very annoying. You're talking to someone, and suddenly you get echo, all of a sudden. This has always been a problem with WebRTC. Google is on it. The other one is screen sharing. Screen sharing is a native part of WebRTC. To be able to push a button and share your screen. Ooh, how exciting. You do that natively within the browser. Lots of problems in making that work reliably, and also for Google, they want it to happen very fast. So some work going on around screen sharing. For the most part, Chrome is a very complicated engine, and WebRTC is a very small part of a Chrome browser, but they're working to isolate problems so that if something happens, it doesn't take down your whole browser. One of the problems with WebRTC in previous generations was that if there was a problem, literally it would crash your whole browser. So they've got some issues. There was problems with audio, there was problems with video. You'll hear about codecs. What's a codec? Guess what? You don't need to worry about codec. No one cares about codecs. The 10 people in the world care. What Google will tell you, as a developer, you don't need to worry about codecs. They handle the codec problem. That's their job to figure it out. And in fact, they're hard at work making VP9, which is, guess what, the previous one, VP8. Very ingenious marketing over there. The purpose is, of course, is to improve the quality and reduce the CPU load. That's always the game. Improve quality, reduce CPU load. And Google's hard at work on that. But wait, by the way, if you're new to codecs, it's always a fun ride because there's always another new codec. The old codec, and there's a new codec. So in fact, there's another codec coming called AV1. Do you need to worry about that? No, not really, but be aware the codecs are always evolving, and people like Google and Microsoft and Cisco are hard at work. And in fact, we'll see this in WebRTC probably sometime in 2018. Again, for you as a developer, do you need to worry about this? No, not really. If you're developing a core engine piece like Lorenzo, yeah, he probably has to worry about that. But it's well on its way. There's all sorts, and the reason for this is there's always arguments about codecs. There's lots of patent issues and licensing issues that are just ongoing into forever. So you as a typical developer, I wouldn't be too concerned about it. We also had WebKit. Apple doesn't like to talk publicly, by the way. So they actually came to Kranky Geek. He works for Apple, but he can't talk as an Apple employee. He talked as a WebKit. WebKit is the open source engine for Apple. So the short answer is that Apple has fully endorsed WebRTC. There's no question, they're on board with it. Dr. Ellis can give you more highlights of things that are going on there, as have Microsoft. Microsoft has another problem that they have to work through. Now, Apple is late to the game, but the good news is this phone right here. I realize they're in Korea and everyone has, who has an iPhone here? Anybody have an iPhone? Look at you, bad Koreans, bad Koreans. The iOS phone today will support WebRTC, which basically means that every mobile smartphone around the world supports WebRTC. That's a very, that's an extremely, there are only two to get. So we've got iOS and we have Android, and they both support WebRTC. So for mobile apps, that's going to be a big, I think we'll see that over the course of the next year. We have Twilio. This is now starting to see where WebRTC starts working with AR, VR. This is a very simple sort of live streaming app. Here's a nice Tesla, and by Rockstars Twilio, showing how you basically can take a live, you're walking down the street, you're showing your car to your friend, and they say, oh, I want it in a blue color. They push the button, and boom, the color of the car changes. So this is augmenting the world in real time. And I think we're going to see a lot more of these. And I particularly think in Asia we'll see more of these, because this is where a lot of the creative thinking comes around. This is my CTO, Baucke. One of the things is, if we're looking for high quality, you need more and more bandwidth. For example, if you're trying to stream a HD movie, that's running at like 20 megabits per second. Is that correct, Daniel? HD movie, very streaming of a movie. What we did here is instead of worrying about keeping the whole picture frame in high resolution, we only care about his face. So what we do is we do low resolution for the background and high resolution. What are you video back? What are you showing? Are you taking a picture of me back there? So we'll take a look at this a little closer. So you can see this up close. Now what he applied was a little bit of logic, and this is again where you have things like edge detection, facial recognition kick in. Instead of worrying about how to transmit more, we worry about what do we care about. So we took his pick. This is here on the left. This would be a normal WebRTC. And on the right, this is basically we tuned it to say, give me better image quality of this person's face. Don't worry about the rest of the scene. So suddenly, trying to make more bandwidth, faster bandwidth, isn't necessarily that important. You really only care about someone's face if you're in a video conversation. We also had Facebook speaking. Are we streaming this on Facebook? You said we were streaming on Facebook. The short answer is Facebook is using WebRTC for Messenger. They have a bazillion number, many people using Messenger, many people using WebRTC. They went through a little bit what they run. Their signaling protocol is MQTT. They went a little bit through a very basic WebRTC. Look, there's no magic here they've done. They just run it at a much larger scale. And they moved from, basically they're able to move from a peer-to-peer to a multi-party conference, classic SFU, selective forwarding unit, technical talk, be careful, Lorenzo, you managed to help me here. But what's interesting is what Facebook is worried about over here. See, this is all great, that's fine. Face tracking, masking effects, we're going to see a lot more of this coming in the next year. So WebRTC will be a transport element, but on the client side, or perhaps even on the server side, we'll be doing things like facial recognition, facial tracking, image enhancement, all without moving the camera around. All of this either being done by, again, on the client or on the server side. Going to be quite interesting. So Slack is taught they're doing 1 million minutes a day, which is not very much, by the way, but it's 1 million minutes a day. Had a very interesting discussion of what they're doing. It's taken them 2 years to build this with a team of 6. So Slack's invested 6 people for 2 years to enable voice, video, and screen sharing within their application. It works reasonably well, and they're very matter of fact about it. What's interesting there, of course, Lorenzo, they're using here, you have the charts here, they're using Janus. I'm sure you can grab him if you have more interest in that. And Slack is, of course, built on Electron, the application you can download with Electron. So they bake Chromium, so they're a native WebRTC app. I know we've talked a little bit about that. Nudity detection. People laughed at that when I said I want to do a talk about nudity detection. Huge problem in the social world. So if you're talking to someone you don't know casually, this is particularly bad and a real challenge in China. There's issues around child protection of children. There's protect me. I'm very, I'm a little sensitive, and so it's not a joke. Companies get shut down if they don't watch after this, including people like Facebook are worried about this. So how do you do nudity detection on live video? Today, if you talk to WeChat, some of the Chinese companies, they literally have people watching monitors, to see if anyone's doing anything inappropriate. Literally, they have thousands of people sitting there looking at monitors. Clearly, that doesn't scale, and of course, there are companies now coming along to do nothing but nudity detection. And of course, I think there's going to be more types of image recognition for different types of detection. I saw in China a very interesting app. Amazing. It's so stupid, but it's a tremendous activity, which is they put cameras into a kitchen, a restaurant kitchen, and they watch the employees, and they know who all the employees are because they do facial recognition. They count how many times the employee washes their hands. I'm not kidding you. It counts how many times that employee washes their hands and whether they have a hairnet on or it's a food preparation big kitchen, because the government, they want for sanitation purposes. They want to show that the employees were washing their hands enough. They want to identify employees who are not washing their hands. So these are some very simple applications with very real meaning. So TikBoat went through how do we do nudity detection using WebRTC, and I need to go back because I skipped past it. Did I skip past it? Let me go back up here. I'm going to miss the great reveal here. See, I'm learning. See, that's Korean for present. So what TikBoat did was show very simple JavaScript client-side implementation to insert. So WebRTC is running and to do some management of the video stream before it hits the WebRTC engine. Now, was it perfect? No, but it wasn't very hard. And so this is Sahi, my colleague here. You can see below here, it's not easy to see. This is how much it thinks there's nudity in the scene, and it jumps up and down. Here it comes again. Here comes Sahi, and Hanson Delvin. We worried about how do you demo this in a trade at an event, right? I had a great idea, no one liked mine. I also think, so here's the secret. So Google is working right now as we speak, at using machine learning for WebRTC, right now. And it's coming not too soon, later, it's coming later. What Google of course collects a huge amount of statistics on usage of WebRTC. Chrome reports certain things back. They also have their Meet and Hangouts, which is probably the leading WebRTC application. And what they've discovered is that they can use some elements of machine learning to make some intelligent choices about how WebRTC behaves. Now here's the bad news. It's not going to be in WebRTC first. Google is going to implement it on their own in another product. However, they've committed, at least to me privately, because they love me, that it will find that the algorithms that they use will eventually be released as a part of the WebRTC core libraries. Probably not next year. I surmise that they have many things going on around WebRTC and machine learning that will work its way into Meet.Google, to Allo, Duo, and some other products that they're planning. There's a lot of things around. I don't know if you have a Google. Do they have Google Home here? You have a Google Home? I don't think so. Google Home is pretty neat. You have the Tmall has the Genie in China, also quite interesting. So there's more to come here. Emil was talking about some early things with machine learning to help figure out how to deal with congestion management, because you start having a bad network connection. How do you fix that? Interesting side note with my buddy Hadar, PureCDN. PureCDN, interesting company to go look at. They are a CDN content delivery network for video. They're using WebRTC data channel to do basically a serverless CDN. Very interesting concept. All client-side implementation. There's no core service other than for reporting. Very interesting company to take a look at. So if you're watching this, Pure 5 back on the list as well, we're taking a look at. The other one is, this is voice-based, talking about natural language processing. So as we know, more and more machines are going to be listening to us. I have a Google Home and I have Alexa in my house, and they talk to each other periodically. But what we're finding out is, in the old days, there were very hard and fast rules. If this, do that. If that happens, go here. Very, very tough gradients, which are very hard stops. If it's over 6, do that. If it's 7, do that. Instead, we're going to see more sort of classic machine learning gradients here, like is shown on the left, to make speech decisions. So a lot of the game is changing. Then we have the folks at Frozen Mountain. This is talking about how you inject it. So you've seen lots of this here. You have a WebRTC client, an SFU, and another client, and they're doing their thing. How do you inject a third-party, sort of a bot here of some sort? And he went through this interesting video. If you have time, take a look at it to show how to inject basically an intelligent processing on top of a WebRTC session. And finally, the god of WebRTC. This is video. This is the CTO of video. You don't know him, but he has had a core video as one of the core developers of WebRTC for 1,000 years. They've been a supporter for a number of years, also for Kranky Geek, talking about how you scale to massive sessions. I think we talked a little bit earlier about how you deal with broadcast type events, not where you have 1 or 2 or 10 or 20, but potentially thousands of people talking simultaneously or in a large session. So that was an interesting talk as well. And that's it. You managed to live through the meetup, so thank you for coming out.
So my question is, when the WebRTC system has to be recommendation. My question to Daniel. Okay.
It's a question for Chris, right?
It's a question.
When the WebRTC standard will become transport as a moment?
You guys know more about that. I don't know. Tomorrow. Don't let Dan take that. That's administration.
Okay. I get that question at every conference and every meetup, every presentation for 6 years now. Yes. So the answer, of course, is very soon. So as always, seriously though, the candidate recommendation stage, you only get to that point when you believe that the document is technically complete. Now, we know that there are still some issues that have to be resolved that might result in another candidate recommendation. However, the main thing that you need is not only for the document to stabilize, but you need reports of implementations. In order to do that, you need tests and a testing framework. So all of this is to say that the work that Dr. Alex has done with Kite is going to make a huge difference here. So back to the prediction for when we'll be done. So it will not happen in less than 6 months. Okay? I think 2 years is way too long for the actual recommendation on the standard. I think it's going to be somewhere in between, probably closer to a year. Dr. Alex was giving an answer that was different for the standard and for the implementations. And I actually disagree with that because they're tied together. You're not going to actually make it to recommendation until you get better support on the implementations. So I think realistically, we're probably looking at 9 months to a year, possibly shorter if Google gets in there and finishes their implementation. We're basically waiting on Google to finish implementing.
아마 사이트에서 하나 있는 거는 이제 4월 달경에 이제 다음이 이제 PR이잖아요. 그리고 이제 그래서 제 생각에는 내년 2분기 수업 그 PR 다음에 레커멘드는 게 짧더라고요. 스터디 해보니까 그래서 2분기에는 레커멘드로 완성되지 않을까 이렇게 생각합니다. Thank you, viewers. 질문 이제 생각나셨나요? 네.
예. 지금까지는 쿠렌토를 테스트하고 있었는데 그게 좀 더 자바나 자바스크립트에 좀 더 친화적이라 생각했는데 자누스 오늘 야누스 발표하신 거 보니까 이제 좀 더 C++ 쪽에 특화되어 있다는 것 같은데 자누스를 자바나 자바스크립트에 좀 더 잘 쓸 수 있는지 그게 좀 궁금합니다.
He's testing. He's using Kurento. Yeah, he's using Kurento, but he's familiar with Java or JavaScript, and he's wondering Janus is for C or C++. But do you have any plan to change it? Do you have any plan to support it to Java or JavaScript or something like that?
No, actually, when I say that Janus is written in C, I'm only talking about the server side. So actually, to talk to Janus, you can use whatever language you want. So you can use JavaScript from the browser. You can, as long as you implement the Janus API, so as long as you can send messages and receive responses and notifications, you can use whatever language you want. And in the slide that I presented, there was a link to the resources page. And there you will find that there are libraries that people implemented to talk to Janus via JavaScript. So let's say you want to implement a Node.js controller for Janus, you can do that. You can talk to Janus from PHP, from Java, from .NET, from C if you want. So you're really free to do whatever you want from the client perspective. So, but the server side is not going to change, so it's going to be C anyway. I don't know if this answers the question.
질문하신 분은 알아들으셨는데요. 그분 말고 다른 분. 질문하신 분은 알아들으셨어요. 너무 길어가지고 짧게 요약하시면.
서버는 서버는 전할 생각이 없고, 그리고 그래서 쪽은
저를 보셔봐요. 뭐. 하나 더. 그러면
One more question. Not two, one.
Sorry, thanks for the answer, but I'm wondering which one is the more better running code comparing the Flat and your Janus? Because I think because you biased.
No, I'm not going to. I mean, I'm going to give the answer that I'm going to give the answer that I give everybody, and I say that there is no better solution. The real question you should ask is not which one is the best, but is which one is the best for me. So as a user, because there are several different open source solutions, and we've seen them in Gino's presentation. We went to Janus, Jitsi, Kurento. There is MediaSloop, there is LeetCode as well. So there are really a lot of different solutions, each one with its own pros and cons. So each one has its strengths, its own weaknesses. And luckily for you, they are all open source. So all you have to do is just play with them all and just see which one works the best for your specific use cases. So, and I'm saying this against my interest. It may be that for your own specific use case, Lorenzo may be better, GC may be better. I really don't know. It's really, you have the freedom to just go through the available solutions, choose which one is the best for you, and hopefully you choose Janus. But I don't know.
I'd like to have a few comments on that. A lot of people think you take one WebRTC SFU and then you can change after. They're all interchangeable. That's not true at all. Each of the 5 or 6 WebRTC SFU you saw on the list before, they implement a special use case. Geek is more video conferencing. Janus is more patching of different plugins together, right? Kranky is even a bigger thing that I haven't figured out yet. And so the problem is you need to think about your use case before you choose the SFU, because you cannot look at all the list of SFU and say, I'm going to choose that one and change the other one. So your question was the easiest to learn. I think the easiest to learn because there is more bigger community and bigger example maybe is Geek today. But it's only going to be interesting to you if you do really, really only video conferencing, right? So it really depends. Finally, in the specific case of Kranky, most of the team of Kranky and the IP and the asset was bought by Twilio. And so even though it's still out there and open source, it's not very active today. That would not be the one I recommend to base the future product on until they really announce what they're going to do in the future, if they're going to support it or not. Because if you end up to have to support all of Kranky yourself, you're dead. It's never going to happen. So you might want to choose also a media server thinking about how big is the community, how active is the community, and if I need help, can I find it? Right? Geek is fantastic, the community is great, you're going to get help from the community. The help for the team is more difficult because they all work for Atlassian. Janus, they work for nobody. It's really easy to find help, but it's going to cost you more, right? Because they consulted. So that's also a key point, I think, to look at when you think about a WebRTC media server. Do not think you're going to pick one and change later. Right? That's not happening.
질문하신 분 다 알아들으셨는데 제가 못 알아듣기 위해서 짧게 요약을 해주세요.
뭐 미디어 서버 여러 가지가 있는데 각각의 미디어 서버의 특징이 있는데 그 A라는 미디어 서버가 B라는 미디어 서버의 특징, 장점들을 다 포용하는 거를 말하기보다는 각각의 특징들을 활용해서 자기한테 맞는 제품을 잘 선택하는 게 좋겠다 이런 것 같습니다.
그런데 이게 말씀해 주시죠. 혹시 더 질문 있으실까요? 왜냐면 미디어 서버 쪽에 관심이 많으시고 많이 시도하셔가지고 미디어 서버 지나가는 거 하나 프레트 쓰시는데
WebRTC 링크
저 말고 직접 질문하셔야 됩니다.
In your presentation, I heard some embedding to the WebRTC native mode. So, is there any application or example? Can you introduce about that? Or you mean client or server? Maybe the client, such as when you want to recording a sound or voice between customer and seller. Someone asked to recording the voice. But I was trying to embed in the WebRTC, but at that time I did not find solutions. After looking your presentation, maybe a gaming solution. They comment on embedding to the WebRTC. So is there some example case for the embedding?
So most of the people that want to do native, they're going to use the Leap WebRTC provided by Google. And on top of that, sometimes you have some wrappers. So on mobile, you have an Objective-C wrapper, you have a Java wrapper, you have some React native wrapper also of the code. In the Leap WebRTC, you do not have a specific class to do the recording. You need to write it. But there is an abstract audio sync and video sync that you can use. clients to do the recording. So this is the kind of service we provide, is to help people with WebRTC to find the right class and to go faster, even to write it for them if need be. So I'm going to let Jordan speak a bit more about the video game case. Another way to do it is to do it through the server, right? Sometimes you don't want to record on the client side. You want to let the server do the recording, or do the transcoding, or change it to something else in between. So I think in your case, you actually send everything to the server and let the server record, right? Not on the client side.
Definitely, yeah. We use some of the RTP forwarding modules and transcoding, post-processing. We work with Lorenzo to make that code put in place for our recording and broadcasting. And but I can definitely see the case of if you had a custom mixer or something like that had a desktop interface or something like that, then using a wrapper around with WebRTC, you could then send that audio off to a device that is connected to the operating system. You might not necessarily have access to through the web browser. Does that answer your question?
Any question? 이건 되네.
제가 기존에 그 레거시 VIP 시스템이랑 야누스를 사용해서 그 SRB 플러그인, SRB 게이트 플러그인이랑 레코드 플레이 플러그인을 사용해서 이런저런 테스트를 하는데 보통 코덱을 H 이루사를 써요. 근데 그 어떤 경우는 브라우저에서 잘 안 되는 경우가 일단 크롬에선 되는데 파이어폭스에선 되는데 크롬에서 안 되고 이런 경우가 있어요. 그리고 iOS 쪽도 테스트를 해봤는데 그 맥에서는 사파리에서는 안 되고 크롬에서는 다 되더라고요. 그런 게 있을 때 저는 WebRTC 쪽을 잘 모르는데 그 코어 쪽에 문제가 있는 거지 아니면 클라이언트 단의 그 구현 쪽에 문제가 있는 건지 그런 거를 좀 그 디버깅하는 게 잘 모르겠더라고요. 그래서 기존에 야누스 같은 경우는 그런 인터오퍼러빌리티 테스트 같은 거 있잖아요. 그게 어느 정도 돼 있는지가 좀 궁금해요.
테스트는 언제 하셨어요?
최근에
최근에요?
네.
최근에 근데 264에 브라우저 대비가 되고
크롬에선 되는데, 그러니까 그것도 연동 테스트예요. 기존 레거시 시스코 시스템이거든요. 그쪽이랑 이제 피어-투-피어 콜을 하는데, 그러니까 맥에서 크롬에선 되는데, 사파리에서는 이게 264 비교가 안 나오더라고요.
사파리에서는 264 있었어요.
그리고 G7이 코덱을 쓰는데 음성도 아예 안 들렸었거든요.
음성은 지금 이제 애플 브라우저에서 해결된 게 있어서 아마 다시 시도를 하면 좀 다른 변화가 좀 있을 거예요. 오디오 쪽에 이런 거 그 정도고요. 영업. 잘 나와요.
She's using legacy VIP and Janus media server, and she has a compatibility problem. In some cases, for example, sometimes Chrome browser works well, but sometimes Chrome browser works well, but Safari doesn't work, and sometimes Safari works, but Chrome browser doesn't work. So she wonders if it's a core server problem or a client problem, and she wants to know how to debug and find what's the problem. She wants the way to find which component makes the problem.
Yeah, no, it could be a problem in either the client or the server. I mean, it really depends on the scenario, on the network, and the configuration of the clients and things like this. In general, we do have two different ways of debugging things in Janus. So on the browser side, you have the Chrome internal things. On Safari, you have something similar that was written by people to implement WebRTC internals on Safari as well to see what happens there in terms of ice gathering, connectivity establishment, and things like this. And on the server side, we have two different ways of debugging things. One is the admin API. It's just a simple query response protocol. So you contact the server and you say, can you give me information about this handle? And the server replies with all the information on the handle, also with respect to the peer connection setup. So it will tell you all the candidates, the local and remote candidates that Janus knows about, the current ICE state, the current DTLS state, if there has been any transmission, statistics with respect to RTCP, and etc. And this is one way. And another way is using the event handlers that I presented in a slide today. So, and that allows you to receive live events from whatever is happening from Janus. So the admin API you ask on a regular basis. So you ask, what's happening now? This is what's happening. Okay, what is happening now? This is what's happening. So you have to ask all the time. Event handlers are asynchronous. So you have your own server somewhere, and the event handlers send you all the events in real time, and so you can figure out what is happening. So if you have problems in establishing ICE connectivity, for instance, if the problem is in DTLS, because sometimes, for instance, one thing that we experienced is that sometimes the problem is in the MTU. So sometimes when you exchange the DTLS handshake, the packet is too big and it's just dropped by the router somewhere. And so this is one of the things that may happen. And in general, these are the two approaches that I suggest to investigate what's going wrong. And of course, there's the usual logs, because for ICE, we use libnice. And so you can enable the logs for this and check what's going wrong, and then maybe capture some things with Wireshark and TCP dump and see why it is not working. In our experience, there are some use cases where Firefox seems not to be able to connect while Chrome instead can. And so it's also harder sometimes to figure out if it's a problem in how we handle things, or if there is a problem in how the ICE stack is handled on the browser and under some circumstances. But I'd suggest, yeah, to check those two alternatives to see if you can gather enough data that can help you understand what's going wrong.
Wow.
If you write me an email, I can send you this information.
So if I analyze that log, do I need deep knowledge about Janus or WebRTC protocol or network?
In general, yeah, there is the best we can do as a platform, as an application, is give you all the information that you need to understand what's going wrong. Because of course, WebRTC is a big specification, so we haven't seen any slide on this, but there are a lot of protocols that are working together for WebRTC to work. And so when something doesn't work, you have to understand there are several different pieces where it might go wrong. And we cannot, let's say, easily automate the understanding of what went wrong and where. So the first thing that I always suggest is collect as much information as you can and try to understand what broke and where. And once you understand where it broke, then you can go deeper. Yeah, no, absolutely. CoStats is a way to collect information, and I was, as I was saying in my presentation, they are using the event handlers when you use Janus as a service. So they receive this live event from Janus, and so they collect information and analyze this and can help you understand what went wrong. So can Epic or Romer or things like this. So there are tools that can help, but in principle, it's also a bit a matter of digging and also doing a bit of digging yourself.
Yeah, with the event handler, can I distinguish? Can I check is it a server problem or network problem or a client browser problem? Can I distinguish it with event handler?
Yeah, no, not easily. I mean, some things are more obvious and some are less obvious when you look at the information that you receive. You look at Chrome WebRTC internals. Sometimes it may be easy to understand the problem because maybe you don't have local candidates or you don't have remote candidates, and that's obvious. Other times,
it's just a logging system, right?
Yeah.
It gives you visibility, but you still need to know if the number is right or wrong. But at least you see the number. It's like I give you a microscope. It's a tool. It's a logging tool. The logging tool never analyzes. It just gives you visibility. So you still need to be able to understand ICE. Usually that's the first thing you look at. DTLS, that's usually the second thing that looks at. If you don't have media, that's all it is, right? If you have media and then you shut down, then you have a bigger problem. So you still need to be a little bit knowledgeable to analyze that. And that's where CoSMo can help, because these events and those mechanisms will give you the data. Then CoSMo will start giving you visibility with a little bit of analysis, right? The same thing. First, the handshake, then the media quality. Depending at which stage you get the error, they can already guess and tell you among the 300 something specification there is in OTC1, I think that's 300. There's only one or two that is possibly the mistake at this stage in the process. And so I like CoSMo for that. I don't have any share, they're not paying me, not a client, right? Because it helps make it easier for people that don't read the 300 specification to find a smaller scope for the problem. Otherwise, the scope for the problem in WebRTC is pretty huge.
답변을 먼저 와 지금 그 질문을 계속 이제 정확해지려고 계속 질문하려고 하거든요.
Could you summarize the answer just in one sentence?
As Alex said, collect as much information as possible. If you can find the problem yourself, then you have all the information that you need. If you can't, you can get help by professionals like myself.
Send us an email. At the end, everybody send us an email. If it's easy, we give you the answer right away. If it's more complicated, we send you a quote.
잠깐 말씀드리면 크롬은 된다고 하셨잖아요. 네, 사파리는 그러니까 크롬은 되시잖아요. 사파리랑 크롬이 WebRTC API가 좀 달라요. 그래서 그러니까 크롬은 옛날부터 지원하는 옛날 WebRTC API를 올드한 API까지 다 지원을 하는데 사파리는 그렇진 않거든요. 최신 표준만 지원을 해요. 그래서 크롬에서 도는 게 꼭 사파리에서 돈다고 보장할 수 없거든요. 그래서 뭐 어댑터 JS를 쓰시나요? 네, 그러니까 안 되시고. 일단은 말씀하신 것처럼 좀 지식이 필요하고요. 아니면 이메일을 보내던가 아니면 최소한 소스코드를 최신 소스코드에 맞게 다시 수정을 하셔야 돼요. 사파리에 맞게. 그냥은 안 되시고.
질문한 거는 굉장히 많은 답변도 굉장히 성실하게 답변해
질문, 네, 먼저 질문인데요. 네, 마지막으로, 그러니까 제가
다른 분 한번 더 한번 따로 이게 그냥 영어 저는보다는
First off, I want to know that you share your presentation because they had no proprietary things for one.
No, we're going to share. Yes.
And I have two questions on this. Yeah.
Let's go, guys.
First one is very how can I pronounce your last name?
Koehncke. Kranky.
I'm sorry.
I come over and give you special lesson.
Okay. Second question is your machine learning work with processing. The result actually to me it's like too good to be true because I understand this object detection process in the video. So the WebRTC can use authenticity or you have your own library like.
So this is all about layering. This is all about layering different technologies together. So WebRTC is very good as a transport and media management program. That's what it does. But what we're seeing now is the layering of other technologies, either pre-processing before the image actually hits, or the stream actually hits WebRTC, or post-processing, which is which one is immediately forked off. Sure, you can. So I think this is just beginning. This is the beginning. I think we're going to see a whole new stage of applications. And in fact, I live in San Francisco. I'm already talking to companies now who are using the gaming area. Some very interesting applications starting to emerge around AR, VR, and then over the AI.
So you mean that you don't have to incorporate or install any some sort of live software?
Yes.
Not that kind of
Yes.
process.
That's correct. That's correct.
So that kind of library contains that feature libraries and APIs.
So I don't think, so WebRTC is not going to change what it's doing, but you will see other technologies surrounding WebRTC.
The very short answer to that is that VR and AR have nothing to do with WebRTC. WebRTC just gives you video. In one way, it does matter. WebRTC gives you high quality video, easily and cheaply. And that is making these other technologies possible.
So for the TokBox example, it's an additional JavaScript library or SDK, and there is no OpenCV in it. So they have their own machine learning algorithm, they have their own computer vision algorithm. It's different from the current tool approach, where they actually mix OpenCV library directly on the server side. Right? So you can choose to switch it on or not. It's
only the video is moving around.
correct.
The algorithm decides on the server side or client side.
You do whatever you want, yes. And they're going to propose something that is on the client side.
I did get a hotel, by the way. I do have a place to stay tonight.
질문은 없으시죠? 그러니까 그게 사실은 회복시키기 어려워요. 이렇게 얘기하는 질문 정말 해외에서는 자주 있어요. 우리나라에서는 사실 처음 있는 일이라 어떻게 보시면은 정말 대화할 게 많아요. 직접 얘기 듣잖아요. 이렇게 고민하는 그래서 그런 자리인데 아쉽게도 저희가 좀 다른 시간이 조금 여의치 않아서 그래서 저희 그룹이 있어요. 우리 그 국가장님이 같이 이제 해서 그룹이 있는데 좀 온오프믹스 있잖아요. 거기서 같이 부르셔서 그렇게 하시면은 그 이외에서 질문 있는 또 이런 행사를 같은 이렇게 좀 될 것 같거든요. 오늘 정말 참석해 주셔서 감사하고요. 국가장님 마지막 말씀하기.
그리고 오늘은 되게 좀 깊은 내용들이 좀 많았던 것 같아요. 그래서 12월 6일 날 그 코엑스에서 WebRTC 컨퍼런스 코리아 행사가 열리거든요. 그때 WebRTC 세션이 3가지가 있거든요.
Now we do karaoke? Okay.
그래서 그날 또 한번 또 오시면 기초적인 내용들이나 프랙티컬한 내용들을 많이 다룹니다. 그래서 그때 한번 또 만날 수 있으면 좋겠습니다. 예, 감사합니다. 네.